Hello guys, this is going to be yet another video in the Excel series. A lot of you have been asking for an Excel video for beginners. So here it is, a basic video on Excel for complete beginners. My name is Yugendra and today we'll be discussing everything you need to know in Excel if you are just starting out. Excel is one of the most underrated software on your computer. It does so much, but we only ever use it for the most boring and tedious tasks. Excel is one of those softwares that we have all used at least a few times but haven't taken it far enough to see what it can really do. In this video, we are going to talk about just that. We will be covering the basics of Excel, which includes entering data in an Excel spreadsheet, navigating through a spreadsheet, using some basic formulas in Excel, creating charts and graphs, using relative and absolute cell references, lookup functions. All of these we will be discussing with the help of simple datasets. But before moving on further with the tutorial, please do like this video and it would mean a lot to us if you could subscribe to our channel for more such videos. Now let us move ahead with the demo.
Okay, so this is how a blank worksheet in Excel will look like, and Excel files are known as Excel workbooks because it may contain a collection of worksheets or rather called spreadsheets. So over here you have a sheet 1 icon which says that this is the sheet 1 of this workbook. So if you want to add 2 or more sheets to this workbook, you can do that by clicking on the plus icon, which is the new sheet icon. So what it does is it adds a sheet to the right of the current selected sheet. So that's sheet 2, which is added on the right side of sheet 1. So now if you click on sheet 1 and click on the new sheet icon or the button, it will add the sheet next to sheet 1 itself, not next to sheet 2. So that you can see using this. As you can see, the sheet 3 is added between sheet 1 and sheet 2. So if you want to add a sheet at the end of, all the sheets, so you have to go to the the end sheet first and then click on the plus button. Over here, you can see that the sheet 4 is added at the end. And now let us move on to the ribbons in Excel. So there are 9 ribbons in Excel. So that's File, Home, Insert, Page Layout, Formulas, Data, Review, View and Help. So let us move on to the File ribbon first. So let's see what it contains. So File is basically if you want to create a new workbook, you can go to File option and then create a blank workbook, and you can save the workbook, you can print the workbook, you can share the workbook, and you can also export the workbook into many other platforms. And Home is basically, it contains all the Excel functions, like all the most used Excel functions. So there's formatting options, which is font formatting, and there's alignment options, and there's number formatting options, conditional formatting options, which we'll be looking in the further part of this video, and cells. You can insert, delete, or either format cells. And insert is something, where we can insert a pivot table, a table, any illustrations like animations or something. And you can insert charts as well, which includes bar graphs, pie charts, and many more, and so much more like this. So in page layout is basically you can set the orientation of the Excel workbook or the worksheet, margins of the spreadsheet, the size and the print area of the spreadsheet, and everything else. So you can set the colors and fonts as well. Formulas is nothing but it contains the formulas which you can use to perform calculations in Excel. So there's Autosum, and recently used formulas are something which we'll be using in the coming part of this video. So this contains the formulas which we have recently used in the worksheet or the spreadsheet. Financial contains all the, accounting formulas. And logical will have all the and, if, not operators. Text is the character or the concat functions which you can use on a particular text. Date and time functions as well. So it has the date value, day, days, and so on. And now if you go to the data ribbon, you'll get import options. So that's you can import any file, any file in the sense, files which are supported by Excel over here. So that's importing files from text or a CSV file, from a web page, from a table or a range, and recent sources. And now if you go to the review ribbon, you have the spell check, the dictionary, workbook statistics. So review ribbon is basically if you want to, check the workbook or a worksheet, check grammatical errors in the workbook, you can use that, the review ribbon. And view is, if you want to change the view of a particular worksheet, you can change that over here. So that's, you have the normal view, the page break view. Page layout is basically, what comes, if you click on page layout, it will show you the layout of the page. So you have the header, footer and everything. This is what the printer will print if you, print the worksheet. So you have around 1, 2, 3, 4, 5, 6, 7, 8, 9 columns in per sheet. You can change that by changing the indentation and everything. That's page layout. And now if you go to the help ribbon, you have the help icon over here. So this can be used when you're stuck somewhere or something in Excel. So if you're stuck in formulating anything or calculating anything, you can click on the help icon and proceed with it. So that's just it about the Excel ribbons. Now let us move on to the home tab and let us see how we can add or enter data in a spreadsheet. Let us undo this first. So yeah, as you can see, the cell selected over here is A1. Now, if you want to enter data into a cell, you just go to that particular cell, click on it and start typing. So now if you want to, let's say if you want to type employee data, you just start typing by clicking on that cell. Now, as you can see, that data seems to be moved to the B1 cell. So that's not the case. It seems like it because employee data is not fit in the A1 cell. So you can increase the size of the cell by going between A and B and then clicking over there and scrolling it or moving the cursor. So now you can see that employee data fits perfectly fine in the A1 cell. Now employee data, it basically contains the names of employees, email IDs and the region that they're working in and so on. So let us fill the first name. And now if you want to move to the next column in Excel, you simply have to press the tab button, which automatically moves it to the next, automatically moves the cursor to the next available cell. So from A2 to move to B2, we need to click on press tab button. So over here, you give the last name and the tab button again, email ID. So let us proceed with these three values for now. Let us increase the size of last name also and email ID also. And now let us fill some random employee names. So let us go with Rachel. The first name is Rachel, and then to go to the below cell from the previous cell, you just have to click on enter. It goes to the next cell down below or the next row. So and now if you click enter, it goes to the next row. Okay, and now over here you give the last name. So that's email ID. You combine both the first name and the last name and at the rate the company. So that will be Rachel dot at the rate xyz.com or something. And now also you can see that .com seems to be in the D3 cell. So what you do is you extend the size of this. So over here and now so what I'll do now is I'll create another 10 employees or so, and then we'll move on to the next part. So that'll look something like this. Yeah, that'll look something like this. So now I've added another 10 employees with their first name and the last name. Now if you want to get the email ID, you can use this way. So Kayla.Peterson @xyz.com. Now Ernest. So what Excel does is it takes the first name and the last name. It considered this as a pattern and it automatically suggested the email IDs for the next employees. So as you can see that the first name over here is Ernest and over here it's Hankard. So that is perfectly fine. What you can do is you can just click on enter to let Excel fill the rest of the details. This is one thing, pretty good which Excel does. Okay, now let us, get the other headings. So there's region. Region is nothing but the region where this particular employee is working. And there's items. Items is nothing but which item that the person has sold. Since this is a sales data set of a company, so you can see that items will have the item which this particular employee has sold, and then rate of that particular item and the quantity of that particular item which has been sold by the employee. So that's quantity. And finally, the total amount. Total amount is nothing but the rate into the quantity. So that's total amount. Now extend this whole column as well. Yeah, so this is one thing. And now I'll fill region and items and show you how the data set will look like. Region, items and rate and the quantity also. So I'll fill those and show you how the data set will look like. Yeah. So as you can see, the region has been filled with south, north, east, and so on. Items consist of vacuum cleaner, toaster, water heater, hair dryer. So basically this dataset is a home appliance company dataset, and the rate of each item is, for vacuum cleaner, it's around 6,999, and the quantity or the number of items, number of units sold is around 14. So this is the, dataset which we'll be working on. And now since rate is currency, we can use the formatting options which will be available in the home ribbon. So select from this particular value. So that's the whole column, which is from 6,999 to 2,399. So even this column is selected, since it's white in color because you've started the selection from this column. But keep in mind that even this column, even this value is selected. So now if you want to, change the formatting of this number, so you go to this number format pane, and over here, click on currency. So as you can see that the currency value has been added over here, and you can change the decimal points as well. So since there is no decimal point, you can just leave it like this. If you want, more than 2 decimal points, you can change it as well over here. So you can increase the decimal places for this. You can see that another 0 has been added towards the right of the decimal point. We'll just remove it now. Yeah. Now you can see that rate has been formatted to, currency. So yeah, this is the data set which we'll be working on. Now to calculate the total amount, what we need to do is we need to, multiply the rate with the quantity. That can be done easily using Excel. So to use any particular calculation in Excel, you need to start with an equal to sign. So that's equal to sign. And keep in mind that whenever you add any value to a cell, this is where you get the value here. So here we've started with an equal to sign, and here also you can see that there's an equal to sign over here. And now Excel does calculations easily by just selecting this particular cell, and since you want the product, we'll click on the shift 8 key, so that's star, and click on the quantity now. So that's F3 into G3. As you can see that F3 is light blue in color, so the cell which is selected over here is also light blue in color, and G3 is light red in color, and the 14 value over here in the quantity is also light red in color. Now if you just click on enter, you get some value which is the product of rate and the quantity. And here you can see that the formatting is already in currency because you've used formatting in currency over here. And now to fill the rest values, you can go to this H4 cell and then you can press equal to. Do the same thing here as well. So that's F4 into, so that's Shift 8 key and then G4. You can see that the product has been formed. And now if you want to fill the rest of these values, you can use the fill handler function in Excel. So which is basically nothing but select these two column or the cells. And now you can see that the plus icon or the cursor turns to a thin plus icon, thin plus button. So when you double click or when you drag that until the end, you can see that it automatically fills up with the product values. So that is how you can use the fill handler function to copy the formulas and get the values automatically in the next rows. So yeah, this is the dataset that we'll be working on now. And now let us format the headings using the formatting functions over here. So let us select all the columns, the heading columns, and make it bold. And let us increase the size to 13 or something, or 12 is enough. Now let us merge these cells into one particular cell, so that employee data will be at the center of all the cells which we'll be working on. So that you can do using the merge and center button or the option in the home ribbon and in the alignment pane. So over here what you can do is you can click on merge and center. It combines all the columns and places the value employee data in the center of all the columns. Now let us increase the size of this font as well. So that's let us make it 15 or something, so that it will look bigger. And you can increase the size of this by clicking over here and extending it. So as you can see now that the employee data is, it is clearly visible and it's big. So let us change the font size to 18 and make it bold. Click on enter, it goes to the center. And now let us move ahead with using some basic formulas in Excel. So as you can see, go to formulas and let us get the max items sold, or the total amount of sales, the maximum total amount of sales for a particular employee or something like that. So let us type the maximum items sold and the minimum number of items sold and the largest amount of sales. That's maximum amount of sales. Let us increase this cell size, and now the minimum amount of sales. Okay, so to use a formula in Excel, remember that we need to always start with an equal to sign. So the maximum items sold is, you have to work on this particular column now. So that will be the G column over here. So the maximum number of items sold will be the maximum. So here you can see that Excel automatically suggests which all function you need to use. So now we want to use the max function, and to use a formula in Excel, after the formula name or the function name, you need to start with a bracket sign and number 1, number 2. So instead of this, we can select this whole range. We want the whole range since we want to get the maximum items sold in this particular column. So that will be G3 colon G16. This is how you define a range in Excel. So our range is now from G3 till the end of G16. So that is how you define a range in Excel. The range will be separated using a colon. And so now if you close the bracket and click on enter, you'll get 15. So as you can see that 15 is the maximum items sold. And now if you want to get the minimum items sold, the same thing can be done. So instead of maximum, now you have to go to minimum and then select the same range. So that's G3 to G16. So that's G3 to G16. Okay, you can see that there's no equal to, and that is why the formula is not happening. So now you can select the range. So that's G3 to G16. And now if you close the bracket, you get the answer as 8. Let us see if that is the least number of items sold. So yeah, that is 8. And now if you want to get the maximum amount of sales, you can use the same maximum and the minimum function to get the minimum amount of sales. But now the range will change because we need to get the maximum and the minimum total amount of sales. So the range will change from G3 to G16 to H3 to H16. So that will be equal to max of, select the range, the total range over here. So that will be this. Now if you click on enter, you get the maximum amount of sales to be 1,59,992. So yeah, the 1,59,992 is the maximum amount of sales, and the minimum amount of sales now can be done using the same way. So that's minimum, min, and then the range. So that's H3 to H16. So yeah, this is how you get the maximum and the minimum number of sales. Now there's something called Autosum over here in the formulas ribbon. Now if you click on Autosum, okay, let us close this. Yeah. So since we need the sum of the total amount of sales, what you can do is you can get the total over here. So that's grand total, and let us increase the size of this cell, extend this column. So now there's something called Autosum in the formulas ribbon in the Excel. So now if you click on Autosum, what it does is Excel takes automatically the values which are present over here. So it doesn't take the string values, it only takes the numeric values which are present in that particular column and then automatically assigns a formula to it. So that's Autosum. So here, as you can see, that the range is from H3 to H16. And now if you click on enter, you'll get the total amount of sales, which is the sum of all the sales values from H3 to H16. So that is the use of Autosum in Excel, where you don't have to use the formula by yourself. Excel does it automatically for you. And now over here, since we got the total amount by using the star sign or the shift 8 key in the keypad, you can also use the product function in Excel. So that is product. So that's PRODUCT, product of F3 into G3. So that's the same again. That will be this as well. So now if you change this value to say 10 or something, this value also changes and the total also changes since formula is already applied to all the range. So that's H3 to H16. And now let us revert it back to 9 itself. As you can see, the value for 10 is around 24,990. Now if you change it to 9, the value will change to 22,491 and the grand total will also change. So you don't have to update it each and every time. The formula changes the value automatically. Okay, so now let's say if you want to get the average value of sales for this all the employees. So let us use that using this function. So that's average amount of sales. So Excel has a function which is called the average. So that's equal to AV. Yeah, as you can see that there's an average function over here. Average of the range would be from total amount. So that's H3 to H16 again. We don't have to select the grand total because it will make the value much higher, the average much higher. So the average amount of sales is rupees 65,109.64 paise. So now you can, see the value in decimal points. And I think if you want to get the more precision value, so that will be go to home and then add another decimal value. So that will be 643. So let's just keep it to two decimal places itself. So that's 64. Yeah, so this is how you get the average value in Excel using the average function. And now let us move on to creating charts and graphs in Excel. Okay, say if you want to picture the quantity in a bar graph, you can do it using the insert ribbon. So in insert, go to charts, and you can also insert charts or recommended charts in Excel. So let's click and see what are the recommended charts that we're getting for this particular data set. So here you can see that the recommended charts have these values. So that's average amount of sales, minimum amount of sales. This doesn't make any sense. So let's go to the pie chart, which has the maximum items sold. Okay, this also doesn't make any sense. So let us, give a chart on our own. So let us create a 2D bar chart on our own. So as you can see, the chart doesn't really look good because all the values in the chart have been included in all the values in the dataset have been included in the chart. So we can filter out the data which we don't want using the filter option over here. So that's chart filters, which looks like a filter icon. Over here, remove these categories. So that's go to names. Instead of all columns, we would need particular column. So that's let's select column A, so that we'll get the names of all the employees. Now if you click apply, you have the employee data total amount chart title, which consists of the rupees and values. So it increases in 2 lakhs. So that's 0, 2 lakhs, 4 lakhs, 6 lakhs, and so on. And as you can see over here, that in the range of the chart, the grand total also has been included. So over here, you can see that there's a big line, which is the grand total. We don't need that now because, we only need the values for each employee, the total sales for each employee. Let us remove that. So go to filters, and over here in the employee data total amount, click on this icon. So that's edit series icon. Here what you can do is you can edit the range of the chart. So instead of H17, make it H16. Okay. And now you can see that the chart value, which the total amount was there over here, it has been removed now. So that is how you can edit the chart series. Now let's say if you want to get the chart for the quantity or the number of units sold for each employee. That also you can do using the edit series option. So over here, go to, names, and over here, go to filters and names. Instead of names, go to values itself and change the employee data total amount edit series. So here H is for, the H column is for the total amount. So as you can see, the G column is for quantity or the number of units sold. So you can change H to G. And as you can see now, you can see that the employee data total amount chart has been updated. So here, instead of the total amount, we have the total number of units sold. As you can see, the chart axis value increases in sets of 2. So that's 0, 2, 4, etc. And on the y-axis, we have the first names of all the employees. So that's Susan, Lynn, Hong, Yen, and everyone else. And over here, the chart value, which has the values for each number of units sold. So as you can see that Susan has sold a total units of 15. As you can see over here, there's 15, and over here also there's 15. So that's 14 plus 1, which is in the center. So that's 15. This is, to display the total number of units sold for each employee. Now you can also edit the chart title or, the chart theme using the chart design option. Over here you have numerous options which you can use it so that you can make the chart look more aesthetic. I'll be using this value, so that's I'll take this to be the chart design for myself. And now this is one way to insert a graph or a bar graph in Excel. You can also insert line graph in Excel. So that's line or an area chart. So let's use the 2D line instead of this. So as you can see over here, this shifts the values to the y-axis and the names to the x-axis. As you can see, this is not that accurate in the sense this doesn't look that good compared to the bar chart. So let us move on to the bar chart again. So that's the 2D bar chart. And you can also insert a 2D column chart instead of the bar chart. So the column chart will make more aesthetic, and it will be easier to get the values for each employee. So as you can see, this is more easier when compared to this chart, which is the 2D bar chart. It depends on your preference actually. So if you want a column chart, you can use the column chart. If you want a bar chart, you can use the bar chart. So this is how you insert charts and graphs in Excel. Now let us move on to the next part of this video. And also, instead of using different data set for each function or each explanation in Excel, I'm using the same data set so that it will be easier for you guys to get the idea of it, get the idea of what we're doing actually. Instead of using different data sets, I'm using the same data set. We'll be using different data sets in the coming part of this video. For pivot tables, HLOOKUP, VLOOKUP and everything, we'll be using different data set tables or data sets for each sections. Yeah, now let us move on to the absolute cell reference and relative cell reference in Excel. Let us move this chart to here since we don't need it now. Yeah, so now since we've already used the formula for total amount, that is product of F3 into G3, and we've already copied the formula to these rows, we'll see what the relative cell reference is. So for this row, the product is between the F3 and this G3 cells, and over here it changes to F4 into G4, and over here it changes to F5 into G5, and so on. So you can see that values are changing, the cell values are changing as and when you go down. So if the cell value changes as and when you go down, it is called the relative cell reference. So relative cell reference is nothing but the cell value, if you're using it in a formula, changes as and when you go down below the row. And since you've copied the formula of this cell and you've copied down the formula for all the rows over here, it changes according to the rows which you've copied that into. So this is relative cell reference. Now if you want to look at absolute cell reference, let us introduce another column called percentage of total amount. So that's percentage of total amount, and let us increase the size of this cell. And now the formula would be equal to the percentage numerator will be this, the total amount, and the denominator will be the grand total. And if you click on enter, you get some value which is 0.107495598, which is I think around 10 decimal points. Since we want the value to be in percentage, let us change the number formatting from this to a percentage. So that you can do it by going to the home ribbon and clicking on the number pane, click on the percent button. So it will change the formatting to %. It will approximate it to the nearest percentage value. As you can see over here that the percent value is 11%. Now let us try copying this formula to the below rows. If you click on the fill handler, drag and drop it till where you want to copy the formula. So as you can see that the values have not been filled because there is nothing below the grand total cell. So over here below this there are no values at all. So what Excel is trying to do is take values from this part, and that is why we're getting the divide by zero error. So to change this, instead of making the formula to be H3 by H17, let us use the absolute cell reference, which is $H and $17. So that will be absolute cell reference. Now if you click enter, you get the same value, but the only difference is when you copy the formula over here to the other rows, you'll get some percentage values. So that is the percentage of this divided by the total value. As you can see over here, the value is H4 divided by $H $17. So this value will not be changed for formulas over here. So let us change this. Just click enter. Yeah, so this value does not change for every row over here. This value will be constant for every formula that you've copied this to. So that is for here it's $H $17, and if you check here also it is $H and $17. So now if you want to check that the percentage function gave the right answer, that you can do by creating the Autosum function or using the Autosum function. Go to formulas and click on Autosum, and that is sum. So the range would be from I3 to I6 itself, and now if you click on enter, you get 100%. Now you know that the formula which we have used and the formula which we have copied using absolute cell reference is correct, so that it is working fine since you got the total percent to be 100%. Yeah, so that is about absolute and relative cell reference in Excel. Now, like we discussed earlier, if you want to import a text file or a CSV file from your system, you can also do that using Excel. So you can see that over here there's an option called from text or CSV in the data ribbon. If you click on that, since I already have a file with the name employee_CSV, you can click on this file to open this particular file. So now if you double click on this, Excel will try to get the values from that CSV file and put it into this format. So now what you can do is you can load this into, so as you can see, I'll show you the CSV file to show you how it looks. So if I open this, so yeah, this is how a CSV file will look like. CSV file is called a comma separated value file, where each value or a record is separated by a comma. So employee name is one string and emp ID is another string, whereas gender, position, department and emp satisfaction are whole other strings. And each value is separated using a comma, which is called the delimiter. So this is how a CSV file would look like. And now if you go back to Excel, this is how it is being imported to Excel. So now if you click on load, it would automatically load this values into the Excel file. As you can see, the first row contains the employee name, emp ID, gender and everything, which is the same over here as well. And the second row contains the employee name, which is Maria Gonzalez, and her emp ID, that is employee ID, which is 198, and everything is same. You can see that the import thing worked for Excel. And also you can see that the sheet name, instead of making it sheet 1, it is employee_CSV, which is the file name itself. Now let's close the CSV file. So, and also you can see that Excel automatically formats it for us. So it has given us a color for this row and alternate colors for these rows. So Excel automatically does it for us. So now if you want to change the theme or the color of these particular rows, you can use that using this pane. So that's table design. So instead of making it green, let's make it red, or you can make it blue as well using this button. So yeah, let's just keep it red itself. So yeah, this is how you import a CSV file from Excel. And you can also import the text file using the same way. So that's data, instead of text, go to text. And if you have a text file which is separated by comma or a space, you can use that as the delimiter. Since it's comma, it is known as a comma separated value file. So that is about importing files into Excel from your system. You can import as many rows as possible because there's no limit on the number of rows. The total number of rows in Excel is around, let us see how many. Let us check on Google itself. So the number of rows, total number of rows in Excel is, as you can see, it's 1,048,576 rows. Whereas the total number of columns in Excel is around 16,384 columns. So there is no limit on the number of rows which you can import from your system, as long as it's below 1,048,576 rows. Now let us go to the end, that is A1. Yeah.
Hi guys, this is Yukendra and today I'll be discussing about VLOOKUP in Excel. VLOOKUP is an Excel function that is used to look for data in a table. VLOOKUP is known to be the easiest way to find values in a table which has a significant number of rows. The idea to sit and go through each and every row and column is a tedious task. This is where VLOOKUP comes in handy. In this video, we will look at the syntax of VLOOKUP function and how VLOOKUP can be used to perform various operations like exact matches, approximate matches, wildcard matching using a small dataset. For this video, I'll be using Google Sheets instead of Microsoft Excel just because Google Sheets is free and easy to collaborate with. And keep in mind that whatever formulas that are available in Excel are available in Sheets as well. Let us now go ahead with the demo.
Now let us look at the definition and the syntax of VLOOKUP function. The V in the VLOOKUP function stands for vertical and it is used to look for a search for values in a table that is organized vertically. Let us look at the syntax of the VLOOKUP function. Always remember that a formula in Excel or Sheets starts with an equal to sign and the function name. Now, if you click on the help icon, you get the arguments which are supported by the VLOOKUP function. So there's search key, range, index, and is sorted. Is sorted can be also known as search options, which have two options, that is approximate and exact match. So the search key is the value which we want to search for. Range is the range to consider for that particular search. Index is the column index of a value to be returned. And the first column in the range is always numbered as 1 and so on. The is sorted argument is optional and it has two values, either true or false. When it is true, it is approximate matching, and when it is false, it is exact matching. We'll see more of that in the later part of this video. Now let us perform some operations including VLOOKUP functions. So this is the data set that we're going to be using. It is the HR data, which consists of 10 employees and their names, gender, position, salary, and the tax percentage, which we'll be using it later in this video. The 2019 day offs and the number of days off in 2020 by each employee. And there is the tax slab as well for each salary. So for 100,000, there's 5% tax. And for 110,000, there's 5.50% tax and so on. Now, if we want to look for the employee ID 1905 and this table, we can do that using the VLOOKUP function. So let's say if we want to look for the position of the employee ID 1905 and this table, we can do that using the VLOOKUP function, and it looks something like this. So the VLOOKUP function, and select the value that you want to search for. So here the value is 1905 that we can select over here. And the range now is from here till the end of this table because you want to search, or you can take it till position also, but let's just take it till the end of this table. That's A2 to I11, and then the column index. So the value of the index is 1, 2, 3, 4, 5. So the position column is the fifth index of this whole table or the range. So let's put it as 5 there. Now you can see that the value is already given over here. Now since you want the exact match, we'll put it as false. and close the bracket. So the value which we get over here is senior product technician. Let us check if this value is correct over here. So 1905, the position is senior technician. So that's correct. And now let us see how it works for the name value. So let us search for Jessica's position using the name, and the same formula is used over here as well. So that's VLOOKUP and the value that you want to search for is this, and the range you want to search for is, let's take from the starting itself till the end of this table, and the column name is 1 2 3 4 5 like earlier, and now false because we want to look at the exact match. Oh, what is this? It says did not find value Jessica in the VLOOKUP evaluation. Now that is because the column which we are searching for is the second column, and the range which we've selected is, like you can see over here, the range we've selected is whole of the table. So always remember that the VLOOKUP function looks for values towards the right of the selected column. So any range which is selected towards the left of the selected column will not be available in the VLOOKUP function. So let's change that to B2 now, because that is the column which we've selected. And now the position changes to 4 because from B2, I mean the from B column, the position has the index value of 4. So that's 1, 2, 3, 4. Now, as you can see, we got the value as area sales manager. Let us check if this is the right answer from here. So Jessica is the first name, so that's here, and then area sales manager. So that is right. And now always remember that the VLOOKUP function is case insensitive. So if you give caps over here, that will work good as well. So let us check that once. It doesn't change. So that conveys that the VLOOKUP function is case insensitive. Many people don't know this, but yeah. Now another way we can use VLOOKUP function is to find the first occurring value of a table. So let's say here we can see that there are 2 Michaels in the first name. Always remember that the VLOOKUP function always gives the first occurrence of that value. So let's see if this works out fine. Now, if we want to get the salary of the first Michael, that is Michael Riordan. So the salary is around 123,500. So let's check that now. So the VLOOKUP function will look like this. Of the value which we want to select is this, and then this, and the range which we want to look at is from here, like we already discussed earlier, here till salary maybe. So the position or the index, column index is 1, 2, 3, 4, 5. And since we want the exact match, it is taken as false. So here you can see that the salary is 123,500 like we discussed earlier. Now we can look at the exact match which we've already discussed earlier. So if you want to, get the employee ID of say 1908, which is Michael. So if you want to get this first name of that particular person, we can do that using the VLOOKUP function only. So that's VLOOKUP and selected value is this C15, and the range is from starting, since the first column is 1908, till, you can take it, since we have till salary, let us take it till salary. And then the position of the first name is the second column, so that's second column. As you can see, we already have Michael over here, and that's false now. Now using the first name, we can find the last name as well. And keep in mind that it gives you the value of the first occurrence of Michael. So here it will be Riordan. So we don't want that now. So let's take the employee ID as the search value itself. So last name will be same VLOOKUP function of the search value is 1908, and then the range is from here till here, and the column name we want is 3, so that's ABC 1 2 3, and now we have Albert, so that's correct. We'll cancel this because it's not needed right now. So here we have Michael and Albert using the employee ID as the exact match which we want to perform. Now coming to the approximate matching using VLOOKUP. Here we have salaries and the tax slabs for each salary. So here we have 100,000 and the tax slab for 100,000 is 5%, and for 110,000 it's 5.50%. Now let us populate this tax percent column using these values. Now here we can see that this value is not present over here, and let us see how VLOOKUP approximates this tax slab for this particular value. So here the VLOOKUP function will look something like this. VLOOKUP, and the value which you want to look up for is this value, and the range will be here till here, so that's L2 to M7, and the column which you want to populate over here is the tax percentage, which is 1 and 2, and since we are looking for approximate values, the argument over here will be true. So here we can see that the tax percentage for 100,000 is 5%. Let us use fill handle to, fill these values as well. Oh, what is this? So now here we can see that some values over here are not available in the VLOOKUP function. So to solve this, instead of using normal cell reference, we'll use the absolute cell reference for this range. So that will be using the $ over here. Now let us undo this first. Let us change this formula to absolute cell reference. So that will be $L, $2, $M, $7. And now let us check if this works out fine. Yeah, so here you can see that it turned out perfectly fine. And for 124,500, it is taken as 6% because it looks up vertically down the line, and keep in mind that these values must be sorted as in ascending order. So here it look downwards to 120,000 and goes to 130,000. Now since 124,500 is between 120,000 and 130,000, it gives the least value out of those to 124,500. So if you look over here, 120,000 has 6% tax, and over here it is given 6% tax. Now we can use wildcards also to give a particular value or to get a particular value. So here let's take Jessica for example. Here there's only one Jessica in this first name column, so let us take Jess instead of Jessica, and now we'll get not available because we haven't used the wildcard yet. So the wildcard function or the VLOOKUP function with a wildcard looks something like this. So that will be H18, and since Jess is in the starting of the name Jessica, so the wildcard will come after Jess. So to use a wildcard, we use the asterisk symbol with double quotes, and rest all the function looks the same. So now if you press enter, you'll get the value as area sales manager. So that is correct. And now if you want to use the last letters of a first name, we can use that as well using the wildcard at the beginning of the name. So let's say if you want Ika, and This will change to not available again. So now this wildcard comes to the beginning of the name. So that'll look something like this: star asterisk and then and. Now we'll get the value again as area sales manager. So this is how you use a wildcard in VLOOKUP function. Now coming to the multiple criterion. So in VLOOKUP, we can use two values and make a helper column to look for a particular value in a table. So here, since there are two Michaels, we can't go about looking for the second Michael's salary using VLOOKUP table. So let's use the helper column to do that. So the helper column should be put before the first name and the last name. So let's insert a column over here. Insert a column towards the left and let's delete this. Okay, now let us name this as helper column. Okay, this VLOOKUP value, we need to change it to C2 now. D15 and that'll be 3. And last name will be 4. Let's cancel this like earlier. And now the helper column value will be equals to this space, and we give spaces and this. So you give and space and this, select this now. So now we can see that the value over here is Maria Gonzalez. So we'll use the fill-lander to fill the rest values. So like we see over here, we have Michael Albert, which is in the same column. So now we can use this column to find out the salary of Michael Albert. So let's use the helper column. So VLOOKUP of, since we want to look for this value, it will be Michael Albert, this column, and the range which we want to search for is over here, and the number of the index column index will be 1 2 3 4 5 6. So now the value is false since we are looking for the exact value. So as you can see, Michael Albert's salary is 150,000 USD. So that is what is given over here. So this is how we use the multiple criterion using the helper column. Combine two columns to find a value of that particular person. That brings us to the end of this video. I hope you're clear with the concept of VLOOKUP function. We have looked at the various operations such as exact match, appropriate matches, multiple criterion matches, and how to use wildcards to simplify your search. If you guys liked this video, make sure you hit the like button and don't forget to subscribe to our channel. Thank you. Hello guys, this is Yugendra and today I'll be talking about HLOOKUP in Excel with a small demo. HLOOKUP is an Excel function that is used to look for data in a table. If a table which is organized horizontally has a significant number of rows, like say 1,000 or more, then I must say this is where HLOOKUP makes a job easier to look for values. In this video, we will look at the syntax of HLOOKUP function and how HLOOKUP can be used to perform various operations using a small data set. For this video, I'll be using Google Sheets instead of Microsoft Excel just because it is free and easy to collaborate. And keep in mind that whatever formulas that are available in Excel are available in Sheets as well. Let us now go ahead with the demo. Now let us look at the definition and the syntax of the HLOOKUP function. The H in HLOOKUP stands for horizontal and it is used to search or look for values in a table that is organized horizontally. Coming to the syntax of the HLOOKUP function, Always remember that a function in Excel or Sheets starts with an equal to symbol and the function name. Over here is HLOOKUP. And now if you click on the help icon, you'll get the arguments which are supported by the HLOOKUP function. So there's search key, range, index, and isSorted. IsSorted is an optional argument. By default, the value of isSorted is true or 1. Search key is the value that we have to search for. Range is the range that we want to consider for the search. The first row in the range is search for the key specified in search key. Index is the row index of the value that we have to return. The first row in the range is numbered as 1 and so on. The isSorted or the search options argument is to convey the type of search that we want to perform on the table. So there are two types of searches. One is exact match and the other one is approximate match. Approximate match is when the argument is true or 1, and the exact match is when the argument is 0. Now let us look at the dataset that will be performing our HLOOKUP function on. So here's the sample dataset that we will be using today. So this is the number of units sold by each employee, which is the sales dataset. So here we have the months of each year from January till December and the names of the employees and the number of units they've sold in each month. So, and there's the total units sold as well. Here we have the bonuses in rupees, which is an empty row. This will be calculating in the later part of this video. And here we have the total number of units sold and the respective bonuses in rupees. So for 100, the rupees in bonus is 0. And for 150, the rupees in bonuses is 0. And so on until 350, the total number of units sold is 350 and the rupees in bonus is 60,000. So now let us move on to some basic operations using the HLOOKUP function. Let's say if you want to find the total number of sales done by Kathy in the month of August, that can be done using the HLOOKUP function. So here it's HLOOKUP function. And then the value that you want to search for. So let's say Kathy. And the range is the whole of this table. So from here till the end row until December. So that is H14, A2 to H14. And the row index will be August. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Because the index always starts from the starting of the range. And now since it's exact, we'll keep it as 0 itself. So that's 0. Now if you press enter, the value is 18. Let us see if this is correct. So Kathy is over here. August month is over here. So the number of units sold by Kathy in the month of August is 18. Now this is using a string. The HLOOKUP function here is using a string as a reference. We can use a cell as a reference also. That can be done using this way. So let's remove the string over here. Now instead of giving a string as an argument, let us select the Kathy row itself or the column. So now the cell reference is D2 over here. Let us look at the value that we'll be getting. The value doesn't change at all. So this can be done in two ways. One is using a string and the other is using a cell reference, which is D2 over here. Now always remember that HLOOKUP function gives the first occurrence of a particular value. So let us try using the string again. So here let us give it as Kathy. Let's edit over here itself. So now you can see that the first occurrence of Kathy is over here and the number of sales done in the August month is 18. So what if we want to get the value of this Kathy? So that can be done by using an extra character, like say the initial of Kathy 2. So that's R maybe. And here you can give it as Kathy R. Now, if you want to change the value over here, instead of Kathy, give it as Kathy R in the string. Now, as you can see, the number of units sold by Kathy R in the month of August is 25, which is over here. Now, always remember that the HLOOKUP function in Excel or Sheets is a case insensitive function. We'll look at the example of that using this name. So, Kathy R, let us change it to lowercase sensitive. So, that's smaller letters. Kathy R. And now, as you can see, the value for August doesn't change over here. Let us see if it's the same value for Kathy R. So August, it says 25, so it does not change at all. Now this can also be done using a combination of lowercase and uppercase characters. So that will be C, small a, capital T, H, Y, and R, and still the value doesn't change. So this means that the HLOOKUP function in Excel is case insensitive. Now let us fill these values using HLOOKUP function and the fill handler. So for April, Charles, the number of units sold by Charles is over here, it's 24. So we need to get 24 over here. So that will be HLOOKUP. And the search value is Charles. The range will be from B2 to H14. And since we want this range to be constant for all the values, we can use dollar symbol before the cell values. So the dollar symbol here indicates that it's the absolute cell reference. It won't change no matter what. So if we use fill handler to fill the rest of the values, the range doesn't change for those values as well. And the row index will be 5 since it's April. So here it's 1, 2, 3, 4, and 5. So April, it's going to be 5. And now since it's exact match, the search option will be false. Let us see what the value is, 24. So that's right. And for July, the index changes. So we'll have to fill that manually. So that will be, let's copy this formula over here, and then use it and change the row index to 8. Change the row index to 8. So that will be 14. And for August, it's going to be 9. The row index will be 9. Now using these three values, you can fill these values also using the fill handler. So that will be drag and drop, go to the corner of the right hand side and then drag the cursor. So you'll get the value. So it says did not find value 31 in the HLOOKUP function. So that means it is searching for E2 over here itself. So that's it is searching for Charles. So that will be, instead of Charles, we'll be using Daniel. So that's G2 instead of E2. I think I've selected the Charles column itself. So let us look over here and then change it to G2 instead of E3. Now, as you can see that the value is 16 over here. Let us change this to, let us use fill handler to fill these values. So it will be 40 for the month of July. Let us see if it's 40 for the month of July. No, it isn't. So let us see what seems to be wrong over here. Okay, instead of G2, it has taken H2. So let's change it to G2 again. And since it's the month of July, it is going to be 8. The row index is going to be 8. So now the value is 22. Let us see if that is right. So for the month of July, Daniel has made 22 units of sales. So here, let us change it to G2 again. And then the value over here, the row index over here is going to be 9 for the month of August. As you can see that the values are filled over here. And now we can use wildcards also to, match using the HLOOKUP function. So for Charles, let us say if you want to get the value of Charles for the month of April. So, let us change this to October to, get the values. They'll be different. And since you want it for October, let us change it to, let's say over here, instead of E2, let us use while character instead. So that's going to be, let's say, char. And since we are using the while character, let us say a star or an asterisk. So that means the first 4 characters that we're searching for is char, and it can be superseded by any number of characters. So since we're looking for Charles, it is superseded by LES. So let us see if this function works. Since we're looking for the month of October, let us change this to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So since the row index is 11, let us see what the output is. So it says 33. Let us check if this value is the same as this value. So the month of October, Charles has made 33 units of sales. So yeah, we can see that the wildcard matching also works. So let us do that for Daniel as well. So it'll be, instead of this, it'll be, let's say, let us use the wildcard at the beginning of the character now. So that will be star and ampersand and the last 3 characters, let's say IEL. Let us see if this works now. Since it's the month of October, the row index changes to 11 like we discussed earlier. So let us see now. Here the value is 20. Let us see what the value for the month of October is for Daniel. So for the month of October, as you can see, the number of units sold by Daniel is 20. Now coming to this value, which is bonuses in rupees, we'll be calculating this for all the employees using this column or the row. So here we have the total units sold and the bonus in rupees for the corresponding total units sold. So here we'll be using the approximate matching instead of the exact matching. So let us use the horizontal lookup function to fill these values. So it'll be HLOOKUP and the value that you want to search for. So it'll be 303. Range is here. So it'll be from 100 till this value. And you can use it as an absolute cell reference because it'll be the same for every value or every total unit sold. So it'll be $G, $21. And then since you want to look at the bonuses in rupees, so it is the second row that we want over here. So that will be 2 over here. The row index will be 2. And since we are looking for the approximate match, we can take the value as true. So you can see that the total number of units sold is 303 over here. So what horizontal lookup does is, and remember that these values have to be sorted in ascending order. So the bonus in rupees, the total units sold have to be sorted in ascending order, no matter what. That's how the HLOOKUP serves through the values. So over here you can see 100, 150, 200, which is sorted in ascending order. So what HLOOKUP does is it goes through each and every value from the starting, and once it goes to 300, it will go to next value, which is 350. Since the value of 303 comes between 300 and 350, it will give the value 300, the value of 300 to this value. So that's 50,000 to the value 303. Let us fill this for all the other columns using the fill handler. Now let us check if 30,000 is the correct value for the total units sold, which is 292. So here HLOOKUP, what it does is it scans through every column. So from 100 till 300 because it is close to 292. So, and then since 292 is less than 300, it scans, it goes to the previous column and assigns that value to 292. So the value which is getting assigned to 292 is the value of 250. So for 250, the bonus in rupees is 30,000. That is what is being assigned over here. Now let us check the same thing for 316. So HLOOKUP, what it does is it scans until 350 because the value of 316 is between 300 and 350. And then what it does is assigns the previous column's value, which is 50,000, to the value 316. And the approximate matching works only if these values are sorted in ascending order. So here you can see that the values are being sorted in ascending order from 100 to 350. And this is how the approximate matching in HLOOKUP is being done.
That brings us to the end of this video. I hope you're clear with the concept of HLOOKUP function. We have looked at the various operations such as exact match, approximate matches, and how to use wildcards to simplify our search. If you guys like this video, make sure you hit the like button and don't forget to subscribe to our channel. Thank you and keep learning. Hello everyone, welcome to yet another video on Excel. I'm Yugendra and today we're going to discuss about pivot tables in Excel. Pivot tables are one of the simplest and powerful tools in Excel. It is simplest because you don't have to use any formulas, and it is powerful because with almost no effort at all, using the pivot tables, we can build good looking reports for large and tedious datasets. In this video, we will be looking at how to create pivot tables, what are the different ways we can portray data using pivot tables, and some of the advantages of pivot tables. But before moving on, for more videos on Excel, don't forget to hit the like button, and it would mean a lot to us if you could subscribe to our channel. So without further ado, we shall now go ahead with the demo.
Let us now create a pivot table for this dataset. But before that, let us look at what the dataset is made up of. So it contains the employee sales data for a company XYZ, and it has the employee names, the region that they've worked in, the items that they've sold, and the number of units that they've sold, with the rate and the total amount. So let us create a pivot table for this dataset now. So to do that, let us go to Insert, and here we have two options: creating a pivot table by yourself or creating a pivot table which is recommended by Excel. As you can see, Excel already has some suggestions for us. So let us see what we can do over here. So if you want to get the sum of total amount by each region, you can select this pivot table and click on OK. So Excel, what it does is places the pivot table onto a new worksheet rather than placing it in the same worksheet. So let us check what the values are given over here. So here you can see the total amount sold in the central region is around 7,20,628, and in the east it's 10,32,785. So this is how you can place a recommended pivot table. If you want to create a pivot table by yourself, you can click on this option, and over here you can select the sheet range which you want to insert the pivot table for. And over here, instead of placing it onto a new worksheet, let us place it into the existing worksheet so that we can work easily. Here you can select the range. You can select the cell which you want to start the pivot table from. So let us select H5 and click on enter. And now if you press OK, there's a blank pivot table where you can add the fields using this pivot table pane. Let's say if you want to get the total amount of sales for each item, that can be done using this. So let's take items and drop it to rows, and then the total amount into values. What it does is it gives the sum of total amount for each item. So for air conditioner, the sum of the total amount of sales is around 16,52,542 rupees. And let's say if you want to know how employees of each region have performed, or want to get the total sales for each region, that can be done using this. So let's take the employee. Let us remove all these now. So over here, get the employee name and put it to rows, and then take the total amount and give it to values. So here you can see that James has total sales of 49,992, whereas Barbara has a total sales of 1,11,993. This is one thing. And if you want to get the total sales by region, remove this, remove the employee name. So let's keep it here. And then instead of employee name, get the region to rows. So here you can see that the central region has around 7,20,628 rupees of sales, and the east region has around 10,32,785, and so on. Since the values that we're looking at is currency, let us format them now. Let us select all the values in the column. If you click on right click, and then you have the currency form accounting number format, and if you click on the drop down, you get the currencies. So what we want right now is the Indian currency, so that's rupees. Let us click on English and India. We'll get the rupee symbol next to the value and the commas at the places. So the grand total now is, it's the same. So the grand total is 48,80,167. Now let us see if whatever changes we do over here, if it reflects in the pivot table or not. So let us remove this now. Let us remove all of this. And now let us get the items and the units. Now you can remove the formatting over here. More accounting formats, and then number. Okay. So now you can see that the number of air conditioners sold total is around 98. So let us see air conditioner over here. Let us decrease the number of units by say 2. So let us give it as 8. Right now the change doesn't take effect. So let's refresh the pivot table. That can be done using left click and then refresh. As you can see, the number of units, the total sum of units have been decreased by 2. So this is how you refresh the pivot table if there are any changes in the main data set. Now let's say if you want to display the maximum number of units sold for an item at the beginning, that you can do it by sorting the values. So over here, if you click on sort, and you can click on largest to smallest, so you can see that the total toasters sold are 112, and the number of vacuum cleaners sold are 105. And you can also sort the values in ascending order, so that should be sort smallest to largest. You can see the least number of items sold are in the couch, and the second least number of items sold are fan and hair dryer, and so on. Also, we can have different ways to display values depending on the fields and the data we are dealing with. So let's say if you want to get the percentage of total sales by each region, we can do that using this. So let us remove all these now. Since we want the percentage of total sales by each region, we want the region over here in the rows. Let's drag and drop that. And in the values, we need the total amount. So as you can see, Central has 7,20,628. Let us format it now. Number format and currency. This is another way to format using number format option. So now let us see how to get the percentage of total sales by each region. To do that, right click and click on show values as. Over here you have many options. What we need right now is the percentage of total sales by each item or by each region. Let's say each region first. So over here you can see the percentage of grand total. We need to select this. Here you can see that the central region has 14.86% sales of total sales. And now let us sort this in descending order. Sort in largest to smallest. So you can see that the west region has sold the highest percentage of sales. And now if you want to get the percentage of total sales by each item, we replace the region with item over here. So let's do that. remove regions, and now let's place items onto rows. So it automatically takes the value. So the air conditioners have been sold for 33.45% of the total amount of sales, and the couches have been sold for 29.71%, and so on. Now let us sort this in descending order too. So sort and largest to smallest. As you can see, the hair dryers have only been sold for 2.98%. So which is the least among all of these. Now, if you want to see the details of the sales of each item in each region, that can be done by dragging items to rows, regions to columns, and sum of units to values. So let us do that. We already have items in rows. Let us drag and drop regions to columns. So over here we have the column labels as the regions and the sum of total amount over here. So since we don't want the percentage now, let us show the values as total amount. So that's show values as no calculation. Over here you have the grand total of each item. So that's for air conditioner, the total number of sales or grand total was 16,22,544. Whereas for the couches, it was 14,40,954 and so on. I think these are already arranged in descending order. Now we have some values which are blank over here. So we can put that to 0 by using this option. So click on this cell which is blank and show values as and more options. Or you can do this also. Go to pivot table options and over here for empty cells show the value as 0. Okay, we got 0 backslash. Let us change that again. So go to pivot table options and over here in layout and format for empty cells you can show it as 0. So as you can see now it looks more aesthetic than the previous thing. Okay, so now what it does is over here we have the regions. So that's west, south, east, central and north and the grand total of each region as well. So in the west the total number of sales was 12,80,950 and in the south it was 11,03,932 and so on. Now let's see if you want to group by a particular attribute. So that can be done as well. Let us move all of these to the pane. Now let us take the region. Since we want to group by the region, let us take region first and then place items below. So here we have the sales of each region and the items as well. So in west, I think almost all the items have been sold and the total amount also is given. And in south, you can see that there's no fan and there's no couch. And I think in east also all the items have been sold and so on. So this is how you group by a particular attribute. Let's say if you want to group by items instead of region. So what it does now is the air conditioner goes to top and couch will also be a separate entity. Let us do that. Let us move these to the pane now. And then since we want the items first, let us drag and drop that first and then the region. So here you can see that the air conditioner is a separate entity, couch is a separate entity, vacuum cleaner is a separate entity and so on. So as you can see, this is more aesthetic than the previous one. And you can see that the couch hasn't been sold in 3 regions or 2 regions, let's say. So that the regions are north and south and vacuum cleaner has been sold in all the regions like you can see. So this is how you use the group by method. Now that we've discussed how pivot tables can be used in Excel, let us look at some advantages of pivot tables. So the first advantage is it is easy to use. All it takes is dragging and dropping the values onto the pivot table pane. You get easy solutions. The second advantage is that we can sort and resort the values like we did. So we did resort the values according to the total sales. So that's sorting and resorting. Now coming to the third advantage, it saves a significant amount of time since we're not using any formulas to analyze and simplify the data set. It saves significant amount of time. Saves time. And the last one, it is quite flexible. If we make any changes to the data set, we can make those changes to get affected in the pivot table with just the click of a refresh button. It's quite flexible. These are some of the advantages of pivot tables.
That brings us to the end of this video. I hope you are clear with the concept of pivot tables in Excel and how we can use them to save time and increase efficiency. We have looked at the various examples such as adding field values into the pivot tables, sorting in ascending and descending order by values, and we also looked at grouping data by different attributes. And lastly, we discussed some of the pros of using pivot tables. If you have any queries or suggestions related to this video, please comment down below and make sure to subscribe to our channel so that you do not miss out on any new tech videos from us. Hello everyone, welcome to yet another video in the Excel series. I am Yugendra and today we're going to discuss conditional formatting in Excel. Conditional formatting is mainly used in datasets which have thousands of rows together. Since there is difficulty in seeing patterns and trends just by glancing through the dataset, conditional formatting makes this job easy for us. It allows us to apply specific formatting to cells, rows and columns to highlight, emphasize or differentiate between data and information stored on a spreadsheet. In this video, we will be looking at how to use conditional formatting in Excel, what are the different types of conditional formatting that we can apply to the dataset, and lastly, how to apply conditional formatting on pivot tables. But before moving on with the video, for more videos on Excel, don't forget to hit the like button and it would mean a lot to us if you could subscribe to our channel. So without further ado, we shall now go ahead with the demo.
Since conditional formatting allows us to apply specific formatting to cells that match or meet a certain criteria, let us look at how we can use conditional formatting on this dataset. But before that, let us see what the dataset contains. So here, as you can see, this is the employee sales data and it contains the employee name, region, items, units, rate, and the total amount. So in the region, it contains south, north, east, central, and west. That is the region which the employee is working from, and the items that they have sold. So these are the house appliances. So there's vacuum cleaner, toaster, water heater, and so on. And the number of units that they've sold, the rate of each unit, and the total amount, which is rate into the number of units. And also, as you can see that there's a pivot table also which I've created over here, which has the items and the total sales amount of that particular item. So the total amount of sales for couches is around 24,83,980 and so on. So let us see how we can apply conditional formatting to this data set. If you want to find the conditional formatting option in Excel, you can find it in the Home tab, and in the Home tab, you can find it in the Styles pane. So over here, if you click on conditional formatting, you have different rules which are already present. So there's highlight cell rules, top bottom rules, data bars, color scales, icon sets, and you can also create a new role based on your condition. And over here in manage rules, you can either edit, delete, or create a new rule. So before applying these rules to our dataset, let us select the range for which we want to do the conditional formatting on. So let's say if you want to apply conditional formatting on this, and the criteria is, let's say if the total sales amount for each employee is above, let's say 80,000. So that you can do it over here. So go to conditional formatting and select highlight cell values and over here you can click on greater than. So let's say if you want to highlight all the values which have sales greater than 80,000, so that can be done over here. Let's say 80,000, and with the light red filled with dark red text. So over here you can see that all the cells which have the amount which is greater than 80,000 have been highlighted. So over here you can see that 80,991 has been highlighted like we saw earlier. Now let's say if you want to highlight all the cells which have sales less than 80,000. So that means over here this value will be normal. I mean, it won't be highlighted. Let's check if that works or not. Let us select the entire column and unselect this cell. And now go to conditional formatting, highlight cell rules. Now let us click on less than instead of greater than. Over here, select the value as 80,000. So that's 80,000. Now, as you can see, all of the values are being highlighted in this column because two rules are being applicable over here. One is total amount less than 80,000 and the other one is total amount greater than 80,000. So obviously all the values will be selected over here or highlighted over here. Let us remove the first rule, which is the greater than 80,000 rule. Over here, the cell value greater than 80,000. Let us delete this rule and apply. And now click on OK. So if you scroll down, you can find the value 80,991 is not highlighted. So that means it is working. So now let's say if you want to find the number of units greater than 10 or highlight the number of units which are greater than 10, that can be done using this. So highlight this column, select this column, unselect units cell. So conditional formatting, highlight cell rules greater than 10. So it will highlight all the values or cells which have the value greater than 10. So as you can see, it works perfectly fine over here. So now let's say if Sam Athwell has sold additional 3 units over here, additional 3 fans over here. So we have to change that value as well. So let's change it to 11 since he sold additional 3 fans. Now conditional formatting, what it does is it highlights this row as well. So we don't need to apply conditional formatting again and again. It automatically takes the value and applies the conditional formatting itself. Let us see if it works or not. So yeah, you can see that it works perfectly fine. Now let's say if you want to get the top 10 values or top 10 highest number of sales, that can be done using this. So let us clear all the rules first. Clear rules from the entire sheet. And now, so click on this and unselect this and go to conditional formatting and go to top/bottom rules. Over here, you can click on top 10 items. So as you can see, the highlight color is light red filled with dark red text. So if you click on OK, you can see that there are certain cell values which are highlighted, and those are the top 10 values or top 10 highest number of sales which have been highlighted. And the same thing can be done for bottom 10 as well. So let us do the same thing. But before that, let us clear the rules. And this time you can select clear rules from selected cells. And now go to conditional formatting again, top/bottom rules. So over here, go to bottom 10 items. And now you can see that the bottom least amount of sales have been highlighted over here. So that's 10,392 and 19,485 and so on. Now let's say if you want to select the whole row or a record which contains an employee who's working from the south region or any region as a matter of fact. So let's go with east region now. Let us clear the rules first and then. So for this we need to select the entire data set. So over here what you'll do is select the entire data set. So that's here. Select over here and then go to conditional formatting. Go to new rule, and over here we can use a formula instead of selecting the already given rules. So the formula here will be, and also always remember that a formula in Excel always starts with an equal to sign. Otherwise, it does not read that it's a formula. So let us give the equal to sign, and over here, since we need the region column, let us take B2, and the B2 value should be, since we're looking for employees from the East region, it should be East. So that's B2 equal to East. And let us give up formatting options. So let us select font to be bold, and then fill, let us select light blue color, so that it'll look fine. Click on OK. So the formatting options have been set, and then if you click OK, so over here it selects only the employee name. So to select the whole row, we can do this. So select the whole data set again, and before that, let us clear this rule first, which is highlighted in red and has bright red text. So go to manage rules and remove this one. Okay. And now go to conditional formatting again, manage rules, and edit this rule. So over here, instead of B2, we give $B2 so that it selects the whole record or the whole row. Now if you click on OK, as you can see that it selects the whole record or the whole row, and the formatting options are bold text and light blue highlighting. So you can see that it is highlighted all the records where the employee is working from the East region. So this is how you select the whole row using conditional formatting in Excel. Now let us do the same thing for the items. So let us select the employees or the records where the items that they've sold is a water heater. So let us clear the existing rules first. Select the rules from entire sheet. So all the rules have been cleared now. And now select the whole data set till 86. And now go to conditional formatting. Go to new rule. And over here, the formula one again. And over here, the formula should be equal to, so since we want the items, so that's C column and second row. So that will be $C2 equal to, since we wanted the water heater, so that should be written in quotes. And now let us click on the format option. Over here, fill, let us use light red color. So that's light red or orange. So let us select this color. It is a light shade of red, and click on OK. And now go to font. Let us use it as bold itself because it will clearly be seen. And that's about the formatting options. And if you click on OK, so this is how the entire row would look like if it is highlighted. And now if you click on OK, you can see that all the values or records which have employees who sold the water heater has been selected. So that is how you can use the conditional formatting to select or highlight the entire row in Excel. And now you can also use conditional formatting this way. So let us clear the rules first, entire sheet. So over here you have data bars and color scales. So data bars is nothing but over here, as you can see, let us select the data set first. So selecting the data set, and then since we want the data bar only for this, let us select only this column and click on conditional formatting. And now if you hover on these values, so as you can see, as and when you hover on these options, there is a change over here as well. So that is, as and when you hover over here, the data bars have been put to that column. So the data bar, the highest data bar is the value which has the highest total amount of sales is higher, and the data bars usually work like this. So the highest value, I think it's 44,19,988. So whatever value which is lesser than that will be taken as a portion of that value. The data bar will be as a portion of that value. So 42,291 will be a portion of this. So the data bar is comparatively smaller when compared to 4,19,988. So this is how you can use data bars in Excel to make it look more aesthetic. And also you can use the color scales. So over here, okay, again let us select the entire column, selecting the column, and then before that let us clear the rule first from selected cells, and then go to conditional formatting, go to color scales now. So over here you can see that apply a color gradient to a range of cells. The color indicates where each cell value falls within that range. So as you can see, green is on the higher end, light green is on the above average end, yellow is average, light red is below average, and red is on the lower end. So as you can see over here, after you click this thing, you can see that the highest value, which is 4,19,988, has been highlighted in dark green, and the lowest value, as you can see over here, it is I think 16,900, and it is highlighted in the color dark red. And let's say the average value which you can find over here is let's say 80,991. This is highlighted in the color yellow or orange. That is how the highlighting works over here. And since we have a pivot table over here, we can use conditional formatting for a pivot table as well. That you can do it over here using this thing. So let us select this value or this value, and if you want to get the bar or a data bar, you can select this thing. So over here you can see that the total value is 73,57,180, which is the bar is completely full. And as you can see, the bar decreases as and when you go down because it is already arranged in descending order. So the highest number of sales for a particular item is for the couches, which is around 24,83,918, and for the AC it's 23,07,359. You can see that these bars are quite close to each other or quite equal, because there's I think only around 1,75,000 difference. So that is how you use conditional formatting for a pivot table. It works the same way like it works on the data set. The only thing you have to do is you select the range and go to the same option, that is conditional formatting. Select the range, go to conditional formatting. Here you can select whatever rules you want to select, or you can create your own rules which you want to give to the pivot table. That is how you can use conditional formatting for a pivot table.
That is the end of this video on Excel for beginners. Today we learned about how one can use Excel for your daily tasks to make it more efficient and simple. This is all you would need as a beginner who is trying to learn Excel. You can play with datasets created by you, or you can download datasets from Kaggle to practice whatever that we have discussed today. For more advanced features of Excel, try to explore a lot of resources on the internet. Microsoft even has a free forum where you can access all the tutorials, the basic ones.
Hey folks, I welcome you all to Scalar Academy's YouTube channel. And this is the first video in the SQL tutorial series. Now, before I start off with today's session, I'd request you folks to subscribe to our channel and also hit the bell icon so that you do not miss out on the notifications. So on that note, in this session, we'll start off by understanding what exactly is SQL, and then we will go ahead and create our first database and table. So before we do all of that, let's understand what is SQL. So simply put, SQL stands for Structured Query Language. Well, that is just the extension of this term SQL. But what can you actually do with SQL? Well, with the help of SQL, you can communicate with databases. Okay, that's fine, but what is a database? Well, whenever you'd have to store data, and if you'd have to store that data in an organized form, you will need a database. So simply put, with the help of a database, you can store your data in an organized form. So let's understand the example of database and tables with a simple example. So I have got this T set with me. I hope you guys can see this properly. So in this T set, what you can consider is this entire thing to be your database. And in this entire thing, what you're doing is you are organizing your data in a proper structured way. So this entire set you can consider to be a database, and these cups which are present inside it, you can consider to be your tables. And if I'd have to simplify it, what I can say is, let's say if you are studying in a college, then your entire college or all of the information about your college would be stored in your database. And in your college database, you can have multiple tables. So you can have one table for student information, another table for the faculty information, another table for the department information. And this is how you store data in tables, and those tables are properly organized in your database. But there's a catch over here. If you'd have to work with the data which is present in these tables or which is present in this database, then you'd need this language called as SQL. Because without the help of SQL, you cannot extract data from these tables. And this is where, my friends, the knowledge of SQL comes in. So with the help of SQL, you can properly either maybe insert data into this table, extract data from this table, or even manipulate the tables which are present inside this. So now that we understand what exactly is SQL, let's go ahead and create our first database and our first table using MySQL Server. So I've opened up MySQL Workbench over here. Now, before I go ahead and create the database, let's again understand what is MySQL and also what is MySQL Workbench. So MySQL is a database management system. So we know what exactly is a database. And again, to work with these databases, what I need is a database management system. And that is exactly what a DBMS means. And we have different types of DBMS. So we've got MySQL, we've got Microsoft SQL Server, we've got the Oracle SQL, and out of these, right now the DBMS which we are using is MySQL. And if I do want to use the GUI tool of this, that is what is known as MySQL Workbench. So as you can read over here, MySQL Workbench is the official graphical user interface tool for MySQL. And now let me go ahead and open my local instance. So this is what you see over here, local instance, and I have to type in my password. So user by default would be root, and then whatever password you had given, just go ahead and type in that. And I have opened up my window. So over here, let me go ahead and create my first database. So to create a database, this would be the syntax. Let me increase the size of it so that you can properly see it. So here I'll write down create a database. And after this, I would have to give in the name of this database. So this create database, what you see are the keywords. So create a database, this is the syntax which you would have to use. After this, just give in the name of the database. Let's say I give in the name of this database as college. After this, let me just put in a semicolon and let me select all of this, and this thunder symbol which you see, just click on that. Now, when you click on that, here you would see that create database college, and here you would see in response, one row has been affected. This should basically mean that I have successfully created my database called as college. Now, after I've created this database, if I have to go ahead and create some tables in this database, I would have to use this database. So for this, I will write down use and then give in the name of the database. So the name of the database is college. So I'll just write down use college. Again, I will hit on this symbol. Again, you will see that use college response 0 rows has been affected. Again, this would basically mean that I have successfully selected this particular database. Now that I have selected the database, this is my opportunity to create a table inside this database. So inside this college database, I would want to create a table called as student. And to create the student table, this would be the syntax. So I shall write down create table. So by default, this is what you would have to write, create table. And this is the syntax to create a table in your SQL Server table or SQL Server database. So I'll write down create table, and then I'll go ahead and give in a name to this. So I'll just write down student. So this would be the name of my table. After this, I will give in these round braces. And inside these round braces, what I'd want to do is I will give in the column names and also the type of the column name. So first, well, if you're a student at a college, you will have a student ID. So for that student ID, I'll just represent that as SID. And then I will give this a data type. So let's say the data type for this is int. Then going ahead, I would need the first name and the last name of this student. So here I'll just have S first name, and the type of this would be variable, character, or var. And over here, let me just give in. So let's say the first name, the maximum length of the first name could be 25 characters. Then after this, the student would also have a last name. And if this student has a last name, I would create a new column for this. And I shall call that column as, let me just write down last name over here. Again, I will give this a data type. So for this, again, the data type would be varchar. Again, the length of this, I will set it to be equal to 25. So here 25 basically means that the length of the first name and the last name could be anywhere between 0 to 25, but cannot exceed 25 characters. And now, so I've created columns for the student ID, student name, the student last name. I would also need another column for the student marks. So here I'll write down S marks. Again, let me put it to be integer. So this is also set over here. Now I have given over here 4 columns, and also since everything is set, I will end this command with a semicolon. So what I've basically done over here is I've created a table called as student, and the student column or the student table has 4 columns. So the 4 column as student ID, and the data type of student ID is integer. Then we have first name, and this is a variable length character, which would basically mean you can give strings over here. And over here again I have last name, where again you'll give a string, and then you have the marks where it is of integer type, and you end this entire thing with a semicolon. Now let me select this entire thing and let me hit on this. And here, if you look at this, you will see create table student 0 rows affected. This again would mean that I was successfully able to create this table called as student. Now let me delete this entire thing, and if I would want to see the table, what is present in this table or what records are present in this table, I have a command called as select, or I have the statement called as select. So here I shall write down select star from, and I would have to give in the table name. So the table name is student. So select star from student would mean that I am selecting everything or all of the records and all of the columns which are present in the student table. So let me select this, let me hit over here, and as you see, I was successfully able to create this student table which had all of these columns. So here I've got the SID, which is the student ID, then I've got the first name, the last name, and S marks. So folks, this is how we can create a database and a table using SQL. So folks, this would be the end of this video. In the next video, we'll see how to insert data items or records into a table. Now, before I end this session, again, I request you folks, If you find this session to be informative, do not forget to hit the like button and also do subscribe to our YouTube channel. So thank you, and let's meet in the next one. Hey folks, I welcome you all to Scalar Academy's YouTube channel. And this is the video number 2 in the SQL tutorial series. In the first video, we understood what exactly is SQL. And after that, we went ahead and created our first database and our first table. And in the second video, we'll see how to insert data into our SQL table. So we'll not at all waste time and open MySQL and go ahead and insert records into the table. So I've opened up MySQL Workbench over here. Let me go ahead and connect to my local instance. And over here, again, I would have to give in my password. And I have opened up MySQL Workbench. And over here in the first tutorial or in the first video, if you remember, we had created a table called as student, and that student table was part of the college database. So my first task would be to use the database. So for that purpose, I'd have to write down use database. Let me also just go ahead and increase the size of the text so that you can see this properly. So here I shall write down use college, and let me execute this. So we have successfully executed this. Now we have opened our desired database. So the name of the database is college, and in this college database we had created a table called as student. Now let me also go ahead and open that table, or maybe just select all of the records which are currently there in that. So for that we had used something called as select star from student. So what this basically means is I have a table called as student, and from the student table I am selecting all of the columns and all of the records, and that is what the star means over here. Let me again hit on this thunder symbol, and as you see over here, these are the columns present. So I have this column called as SID, then I have another column called as S first name. After that I have a column called as S last name, and then going ahead I have a column called as S marks. But you see that this entire table is empty because we have not yet inserted any data items into this table. So this is what this entire video is about, and in this video we will see how to insert records. So let me just go ahead and do that. Let me decrease the size of this. So here, let me just remove this out. And let me see if I can track this down properly. Seems like I cannot do that. So instead what I'll do is I'll just write down the command to insert data items. So what I'll do is I will write down insert into. So here you'd have to properly remember the syntax. Insert into are the keywords. This is what you'll give. After this you will give in the name of the table. And what is the name of the table? The name of the table is student. So you shall basically write insert into student. Then you will have to give in another keyword which is values. After that you have to give in 2 round braces, and inside these you can give in the values. So the first value is student ID. So let's say the first student ID is 101. Then I would have to give in the first name of the student. So let's say the first name of the student, and also if you remember the first video properly, you would know that the first name, last name are basically var-char type columns. And over here I can give in string data type, and whenever I'd have to give in a string, I will enclose that in double quotes over here. So first name, so let's say the name of the first student is, I will write down Annie, and I would have to give in the last name as well. So let's say the last name of this person is Cleopatra. So student ID is 101, first name is Annie, last name is Cleopatra, and I'd have to give in marks as well. So let's just say Annie Cleopatra has scored around 87 marks. Now I will put in a semicolon over here, and I'll select this entire thing, and I will hit this thunder symbol. And we have successfully inserted this into our table. Now, just to verify this, what I'll do is I'll delete this entire thing and I shall again write down select star from student. And now, if I hit this thunder symbol, you will see that I have inserted these values. So, we've inserted the first student or the details of the first student. So, SID is 101, first name is Annie, last name is Cleopatra, and this person has scored 87 marks. Now, similarly, if I would want to insert the details of the second student, I'll do the same thing. So let me just write down insert into, then I need to give in the name of the table, which would basically be student, and I will give in the keyword values. Again, given this round braces over here, now let's say the next student ID is 102. Now, the name of this person is, let me just write down John, and the last name would be Smith. So let me just write this down properly. So this person's entire name is John Smith, and John Smith has scored, let's say, 56 marks. And let me end this syntax with a semicolon. Now I'll select this entire thing, I'll click on this, and we have again inserted this. Now, just to verify, I'll delete this. Again, I will use the select statement. So I'll write down select star from, and I would have to give in the name of the table again. So the name of the table is student. Let me write down student over here. Let me end this with a semicolon, and I'll execute this. So right now you would see that I have also inserted the second record where the student ID is 102, student first name is John, student last name is Smith, and this person has scored 56 marks. So folks, this is pretty much it for this video where we have learned how to insert records into a table. So on that note, I will sign off, and before we actually end this video, I request you folks that if you found this session insightful, do like the video and also subscribe to our channel. So thank you very much, and let's meet in the next one. Hey folks, I welcome you all to Scalar Academy's YouTube channel. And this is the third video in the SQL tutorial series. And in the previous two videos, we learned how to create a table and also how to insert records into our table. And in this particular session, we will see how to work with the where clause and filter out records on the basis of this where clause. So before I actually head to the coding, I request you guys to like this video and also subscribe to our channel. So on that note, let me open up MySQL Workbench. So I've opened up MySQL Workbench over here. Let me go ahead and select my local instance and also put in the password. So the password, I'm typing it over here. Let me hit enter, and we have successfully opened up our local instance. And I would again open up the student table which we had created in the previous video. Now, if you would want to know how to actually create a table and insert records into a table, you can follow the first two videos, and you will find the link for these two videos in the description below. So if you don't really know how to create a table and also how to insert records, I request you guys to watch those videos first and come back over here. Now let me go ahead and open up my student table. And before that, I'd actually have to select my database. So the student table I had created in a database called as college. So here, now before I write this, let me also increase the size of this so that you can see this properly. So here I shall write down use, and then I shall give in the database name. So the name of the database is college. After this, I'll just give in a semicolon. Let me select this and select this thunder symbol. And we have executed this. Now that we have selected our database, so in this college database, I have a table called as student. Let me go ahead and open up all of the records which are present over there. So here I shall write select star from, then I need to give in the name of the table. So the name of the table is student. Now let me select this again, and as you see, I have opened up the student table. And in the student table, I've got all of these columns: student ID, first name, last name, marks, and gender. Now, in this video, we are supposed to work with the where clause, and with the help of where clause, we can filter out records on the basis of a condition. So let's say from this entire table, I would want to extract only those records where the gender is equal to male. Let me go ahead and write down the command for that. So I'll start off by writing select star from, and after this I need to give in the table name, which would be equal to student. So till here what we're doing is we're just using the select query. After this we will give in the where clause. So here I shall write down where, and as you see, even the color of this where clause has turned to blue because this is a keyword. So I'm writing select star from student where. After this I need to give in the condition, and the condition is s underscore gender. This needs to be equal to male. So from this entire table, what I'm doing is I'm extracting only those records where the gender of the student is equal to male. Let me select this entire thing. Let me press this. And now if you see, I have extracted only those records where the gender is male. Similarly, let's say from this entire table, I'd want to extract only those records where student ID is equal to or greater than 103. So this where you see, so this is actually a numerical entity and the ID start from 101 go up till 105. What I'd want is I'd want to extract all of those students whose student ID is equal to or greater than 103. So here I shall write select, let me write this properly. So select star from student, and after this I again given the where clause, and after the where clause I given the condition. So the condition needs to be SID is equal to or greater than 103. Let me actually change this and make this greater than or equal to 103. Let me select this entire thing and let me run this. Now, as you see, the SID over here, it starts from 103 and goes up till 106. Now, let's say if I want the student IDs from 104 or basically upwards of 103, then I shall remove this equal to symbol from over here. Now, if I run this, you shall see that I've extracted only those records where the student ID is greater than 103. And that is why I have 104, 105 and 106. Now, after this, let's say if I'd want to extract records on the basis of multiple conditions. So here I can use the AND operator as well as the OR operator. With the help of AND operator, I'll be basically extracting those records where both of the conditions are satisfied. So for that, let me show you the entire table for you guys again. So I shall again write down select star from student. Now from this, what I'd want to do is I'd want to extract those students where the gender is male and marks scored by the student is less than 50. So if we see from this entire table, we see that there is only one particular record where the gender is male and mark scored is less than 50, which is basically this student, and the name of the student is Matt Cooper. So for this, what I want to do is I'll again start off with the same thing. So we shall have select star from student. After this, I shall give in the where clause and I will follow it up by giving both the conditions. So let me give in the first condition. Select star from student where the first condition needs to be gender. So I shall write S gender is equal to, let me write down male over here. After this, I shall integrate it or combine it with the second condition using the AND operator. So this what you see is known as the AND operator, and with the help of this I can combine two conditions together. Select star from student where S gender is equal to male, and the second condition needs to be S marks. Let me write this properly. So S marks needs to be less than 50. Now I shall select this entire thing and I shall execute this. So as you see over here, there is only one student and the student is Matt Cooper, and as you see, Matt Cooper, his gender is male and his marks are less than 32. Now, after this, I would go ahead and show you the entire table again. So let me write down select star from student, and these are all of the records over here. Now again, let me show you another command with the help of the AND operator. So here, now let's say I want all of those records where the gender is female and marks are greater than 50. So let me also write a command for that. So here I shall write select star from student where after this I need to write down and to give the first condition, and this time the condition would be S gender is equal to female. I'll follow it up with the AND operator and then given the second condition. So the second condition is S marks greater than 50. Now let me execute this. I'd have to write from over here select star from student. Now let me execute this, and as you see again, there is only one student and the name of the student is Annie Cleopatra, whose gender is female and who has scored 87 marks. Now we'll go ahead and work with the OR operator. Now before I do that, let me again show you the entire table. So I shall again write down select star from student. I'll execute this, and from this, let's say I want all of those records where either the student ID has to be less than 104 or the marks of the students are greater than 50. So what I'm doing is I'm basically giving in two conditions over here. The first condition is the SID needs to be less than 104 and the marks needs to be greater than 50. So by that condition, seems like we'll be extracting all of that. So what I'll do is, since I want both the cases, so I shall maybe put in the gender condition. So either what I'll do is the SID has to be less than 104 and maybe I'll put the gender as equal to female. Let me just write that down. So select star from, I shall write select star from student where the first condition needs to be S underscore ID is less than 104. After this, I shall write down, I'm giving an OR operator over here and I'm combining this OR operator with the next condition. So the next condition would be S underscore gender is equal to female. And let me go ahead and execute this. So here what is happening is if either of these conditions is satisfied, we'll get the result. So what we'll get is, so we've got 6 records over here and with the help of this condition. So this says if student ID is less than 104, which would mean that we'll get the top 3 records over here. And along with that, since we're also giving in the second condition, which is S gender is female. Now here, even though the student ID is 106, which is greater than 104, but as you see, the gender is female, and that is why we'll also get this particular record. So let me select this entire thing. Let me run this. And as I've told you guys, from the entire table, I have extracted those records where the student ID is either less than 104 or the student gender is equal to female. So folks, this is how we can work with the where clause and filter out records on the basis of this. So thank you very much for attending this session. And again, if you found this session insightful, please do like this video and also subscribe to our channel. And we'll meet in the next one. Thank you.
Hey folks, I welcome you guys back to Scalar Academy's YouTube channel. And in this particular session in the SQL tutorial series, we shall work with the update query. So till now we've seen how to create a table, how to insert records into the table. Now with the help of the update query, we shall see how to modify the records which are already stored in our table. So what we'll do is we'll directly open up MySQL Workbench and start working with the update query.
So I've opened up MySQL Workbench over here. Again, I will click on local instance and let me go ahead and give in the password. And we have our MySQL Workbench right over here. Now my task would be to select the database and open up the table. So the database which we were using was college. So here I shall write down use college. Let me select this and I will click on this button. So I've selected the database. Now what I'll do is I'll go ahead and use the table which is present inside this. So the name of the table is student. So to look at all of the records which are present in the table, I shall just write down select star from student. Now again, I will click on this and as you see, these are the different columns which are present and these are all of the records. So as of now, it seems that we've got 6 students and we've got their names, we've got their marks and we've got their gender respectively in this table. Now, what I'd want to do is, let's say if the marks which Anne Cleopatra has scored, it's actually 97 and not 87. There has been a mistake while storing the data. What I'd want to do is actually change that. And for that purpose, I can use the update query. So here, this is how I would change the marks which are stored as 87. I would want to change that to 97. So let me just write down update. So this is how I'll start. I will start off by writing the keyword update. Then I shall give in the name of the table. So the name of the table is student. So update student. After this, I shall again use the keyword set. And I would have to set S marks to be equal to 97, where the first name is equal to Anne. So here I shall select where S underscore first underscore name is equal to Anne. So what I'm doing is I am changing the value of marks from 87 to 97 where the first name is equal to Anne. Let me select this entire thing. I'll run this properly. So seems like we have an error over here. You are using safe update mode. So normally what happens is if we are trying to update something and by default in your MySQL server, if it is in safe mode, you cannot update it. So we'd have to turn off the safe mode. So to turn off the safe mode, this is the command which I'd have to use. So I'd have to use set SQL safe updates is equal to 0. Now I'll select this. Let me run this now. So as you see, this has been properly executed. Now again, I'll select this update query and I will select this. Now this has been successfully executed. So now that I've made the changes, let me go back and open up my table. So here I shall write down select star from students and let me run this and let me see what would be the result that I get. So I'll select this again. So this has to be student if I'm not wrong and not students, and I'll click on run. So as you see, initially the marks which Anne Cleopatra has scored were 87. With the help of the update query, I was able to update it or change it from 87 to 97. Similarly, we've got another student over here. So we've got David Leon and he scored 92. So, but it seems that this again is incorrect and David Leon had in fact scored 62 and not 92. So let me also change that. So what I'll do is I'll write down update, then I shall give in the name of the table which is student. So update student, then I'll write set. And after this, I'd have to give in the name of the column. So the name of the column would be S marks. Update student set S marks is equal to 62, where now in the where clause, I'll actually use the SID instead of S first name. So here this person's name is David Leon and his SID is 103. So here I shall write where SID is equal to 103. Now I'll select this entire thing and let me run this. So again, I've executed this. Now let me go ahead and select my table. So select star from student and let me run this. And as you see over here, initially marks scored by David Leon were 92. With the help of the update query, I was able to change it to 62. So folks, this is where we learned how to work with the update query. And if you do want to learn about the other basic things in SQL, such as how to create a table, how to create a database, or maybe how to insert records into the table, You can watch our previous videos and you'll find the links for the same in the description below. So now before I end this class, I'd request you folks to like the video and also subscribe to our channel. Thank you very much and let's meet in the next one.
Hi everyone, my name is Devi, and in today's video I will be discussing joins in SQL. I'll be discussing the different types of joins that we have in SQL, and I'll also show you how you can run those join queries in MySQL. But before moving on with the video, I would request you to kindly like this video and subscribe to our channel. Alright, so starting off, first we have a brief introduction of join statements. As you can see, join statements in SQL are used to combine data or join columns from two or more given tables on the basis of a common field between them. Suppose you have two or more different tables and you want a single table consisting of different columns, say one column from one table, another column from another table, and so on. In that case, you could take help of join statements in SQL and obtain a single table with different columns from the different tables. Then we have different types of joins in SQL, but in this video we'll be covering inner join, left join, right join, full join, and self join as well. So to begin with, first let's take an example. As you can see on the screen, we have two different types of table. The first table is the student table, which contains four different columns: roll number, name, address, and age. Then we have the second table, which is the course table. The course table contains three different columns, as you can see: serial number, course ID, and roll number. So the first join that we have is the inner join. Now the inner join or join keyword is mainly used to select all rows from the given tables for as long as the condition remains satisfied. Now the resultant table that you get is formed by combining all rows from both the tables where value of the common field will be the same. So, as you can see, the syntax for inner join is given right here. It goes like: select table 1 column 1, table 2 column 1, from table 1 inner join table 2, on table 1 matching column equals table 2 matching column. Now here, table 1 refers to the first table, table 2 refers to the second table, whereas matching column refers to the common field between the two given tables. Now for the given tables, the inner join query would be: select course ID, student name, student age, from student inner join course, on student roll number equals course roll number. Now what this inner join query does is that it gives you a single table which contains the three columns: course ID, name, and age. And these columns are taken from the two tables, student table and the course table. And also this is done on the basis of the given condition that the roll numbers must be matching. Here you can see the output or the resultant table on the screen. There's the course ID, name, and age. Moving on, the second type of join that we have is the left join. The left join, which is also known as the left outer join, returns all the rows of the table on the left side of the join and matching rows for the table on the right side of the join. The resultant table that you get displays null value for those rows which have no matching rows on the right side. You can see the syntax for left join here. Select table 1 column 1, table 2 column 1, from table 1, left join table 2, on table 1 matching column equals table 2 matching column. Now for the given set of tables, the left join query would be: select course ID, student name, from student, left join course, on student roll number equals course roll number. What you get from this left join query is a set of these two columns, which is course ID and name, and this is given in the form of a single table by joining the student and the course table on the basis of the given condition. You can see the output or the resultant table on your screen. We have the course IDs and the names, and these data is associated with the same set of roll numbers. Okay, so the next type of join that we have is the right join. Right join, which is also known as the right outer join, is quite similar to the left join, but the only difference between the two is that the right join returns all the rows of the table on the right side of the join, and matching rows for the table on the left side of the join. The resultant table that you get displays null values for those rows which have no matching data on the right side. As you can see, we have the syntax for right join right here. Select table 1, column 1, table 2, column 1. From table 1, right join table 2 on table 1 matching column equals table 2 matching column. For the given set of tables, the right join query would be select course ID, student name from student, right join course on student roll number equals course roll number. What you get from this right join query is a single table which contains the columns course ID and name, and this is done by joining the two tables, student and course table, on basis of the given condition in the query. You can see the output or the resultant table here. Here we have the course IDs and the names, and also we have null values in the course ID column wherever there is no matching set of data. So the fourth type of join that we have is the full join. Now the full join is nothing but a combination of both left join and right join. The output table that you get from full join contains all rows from both the tables, and also the resultant table contains null values for the rows which have no matching set of data in any of the tables. Here you can see the syntax for full join. It goes like select table 1 column 1, table 2 column 1, from table 1 full join table 2 on table 1 matching column equals table 2 matching column. Now for the given set of tables, the full join query would be select course ID, student name from student full join course on student roll number equals course roll number. Now what you get from this full join query is the output or the resultant table which you can see on your screen. Here we have all the course IDs listed on the left side and all the names listed on the right side of the table, and also you can see the null values wherever there is no matching set of data available. Now the last type of join that we have is the self join. The self join statement, as the name suggests, is used to join a table to itself. Each row of the table is joined with itself as well as all the other rows available based on some given conditions. The syntax for self join is select A column 1, B column 2 from table name A, table name B, where given condition. Here, the table name refers to the name of the table that you are joining, and the given condition is the conditions based on which the rows are selected. Alright, so for the given set of tables, the self-join query would be select A roll number, B name from student A, student B, where A roll number is less than B roll number. Now the output that you get from this self-join query looks something like this. Here you have the set of roll numbers, and on the right hand side of the table you have the set of names. This table is obtained on the basis of the given condition that you have here in the query. So now I'll show you how you can run these join queries in MySQL. Here on the screen you can see the MySQL workbench. So let us see how we can run those queries. So on the left side of the screen you can see the list of schemas. Now, I have already created a schema or a database that we are going to work with today. Here you can see the database that I have created, user_db1. And I'll also show you the tables that I have created. Here's the student table. I'll show you the student table right here. You can see roll number, name, address, and age. It has all these 4 columns. I've also created another table, which is the course table. You can see the course table right here. Serial number, course IDs, roll numbers. All of the data is present right here. So now let us begin. First, you can see here's the workspace. Here's the area wherein you can write your queries. First, let us see all the default databases that we have. This is the query you use for seeing all the default or existing databases. As you can see, we have these default databases and the database that I have created, user_db1. So today we'll be working with this database. And okay, so The first query that we are going to run would be the query for inner join. So let me just quickly type in the query. Select course ID. Then we have student name. From student inner join course, we have on student roll number equals course roll number. Alright, so now I'm quickly going to run this query and see what we get. As you can see, we have the resultant or the output table here. We have the course ID and the names. Okay, so moving on, the next query would be the query for left join. I'll just quickly type in the left join query. We have select course ID. Then we have student name. From student left join course on student roll number equals course roll number. Okay, so here's the query for left join. Now I'll run this query. Okay, so now you can see we have the output right here. We have the table which has course ID and the name. Also, we have null values wherever there's no matching set of data. So moving on, the third query that we are going to run is for right join. So I'll just quickly type in the query. Select course ID. We have student name. From student right join course on student roll number equals course roll number. Okay, so here's the query for right join. I'll just quickly run this query. As you can see, we have the output of the resultant table right here. We have the course IDs and the names and null values for wherever there's no matching set of data. So now, coming to the full join query, let me just tell you that the full join keyword is not supported by MySQL. So what you can do in this case is you can use a combination of left join, union, and right join keywords all at once. I'll just show you how you can do it. First, you need to type in the query for left join. This is just the same query that we have run previously. Student name from student left join course on student roll number equals course roll number. So here we are done with the left join query. Then you need to type in the keyword union followed by the query for right join. Course ID, we have student name from student right join course on student roll number equals course roll number. Now we are done writing the query. Now I'll just run this query and see what we get. Here you can see we have the resultant or the output table with the course IDs and the names and null values for wherever there's no matching set of data. Okay. So the last query that we have for today is the self-join query. Select a roll number. We have B name from student A, student B, where A roll number is less than B roll number. Okay, so here we have the resultant table or the output table with all the roll numbers and the names based on the given condition in the query. So I hope you're clear with the concept of joins in SQL. In this video, I have discussed with you the brief definition of join statements. I have shown you how you can run all the join queries in MySQL. I hope now you're clear with the concept. If you like this video, please don't forget to hit the like button and also subscribe to our channel. Thank you.
Hi everyone, I'm Naman Bhalla, and today in this video we are going to discuss about SQL queries and some of the common type of questions that appear regarding to SQL and basics DBMS knowledge that is required if you want to be good in DBMS. So the topic for today is SQL interview questions and concepts. Okay. So today we are going to first start with a basic coverage of different concepts that you need to know before you even start diving into doing SQL queries. You must know that, okay, how data is arranged, how to arrange data, how to structure your database in a good way, such that it is very fast on the queries that you have to do and all other things, okay? Great. So let us first begin with what even data is and why is data important, okay? The efficiency of any company, any business depends upon the data it has. Okay, I'm like the user data that you have, or you have the data about how people are behaving, and that information is very relevant for you to make business decisions. Okay, so data is of prime importance and at the core of a company's functionality. Okay, now how will you arrange data? To arrange data, you need some kind of system, right? What can be those systems? One very basic way to arrange the data can be, hey, that let me just actually create a file, and suppose I have a data and my data is something about, let us say that we are developing database for a system, okay, for a university. So what will be my data like? Let us say that I am a university. So my data can be like something about students, right? I can have some data about students. I also can have some data about my faculty, right? Or my employees. Let us say for now, let us keep it short and let us say that we have only data about these two things. Now, how might I save it? One way to save it is very rudimentary way that, hey, let me actually create a lot of files on my machine, and then in those machines, let me store the data. So let us say that there is a file, something like students.txt. And let us say that there is another file that is employees.txt. And then suppose you have multiple students. Let us say that there is a student who has a roll number 1 and his name is Abhay. And suppose he has a batch. Let us say that we are storing these three information. We store it something like 1, Abhay, and let us say it is 2016. So that is a very fine way to store data. There is nothing wrong with it, right? But is it a good way to store data? That depends. That depends upon what kind of data that you have, right? So that is where the concept of a database management system comes. That, hey, how will you even store the data? What optimizations will you do so that the storing data is relevant to you? Because you don't just store data, you also use it, right? So you have to do some queries upon it. You have to also fetch the data back again to make some business decisions or resolve some queries, right? So there are two important decisions that you need to do. The very first decision is storing the data, and the second thing is querying that data, right? Without these two operations, our database management system is irrelevant to you. Okay. So our DBMS is nothing but a system software that allows you to store the data and query the data, along with providing a lot of security constraints and other things, which we will tell as we go into this video. Okay. So those are the primary two things that we need to maintain with us. Okay. So that is what a DBMS comes from. How can we structure a DBMS? One way to structure, I mean, like, how will a DBMS inside itself structure itself, right? So the one way can be like even a DBMS maintains a file. That is a fine way to structure. That might be something like it is maintaining documents. Okay. Can there be any better way to structure your data inside a database management system? What do you store the data about? In your computer, you store the data about some things, right? You store the data about something. Like here, you were storing the data about students. You were storing the data about employees. Suppose there is also users. You have some, let us say that probable students or people who have applied to you. So there might be something like applicants, which you are storing the data about. Okay. So you are storing the data about something, and for each student, for each thing that you are storing data about, you are storing some things about that thing, right? So these things that are called as entities. So entities are nothing but about what or about whom are you storing data. Okay. And about whom you are storing data, and what data are you storing, right? You are also storing some kind of data about things. Like for example, for students, you are storing the roll number, you are storing the name, and you are storing the batch ID. That depends upon the business decision as to what you want to store. So there are two things. The very first thing is the things that we are storing the data about, which, as I told, is called as entities. And then there is attributes or fields. What data about entities are you storing? Now, let us consider our real world use case. Is data in silos? No. There is always a connection between one data and other data, right? So for example, for a student, let us say in a university, you might also need to maintain that which courses have been enrolled by a student. So somehow you also need to maintain a course enrollment data set, right? So let us say that another kind of entity can be course enrollment. For course enrollment, what do you need to store? You might need to know that what is the course number, and also you might need to store that who is the student who has enrolled for that course. So let us say the two things that you need for a course enrollment is nothing but a course represented by an ID, and also a student, which is probably represented by a roll number. Okay. Now suppose these are the three data sets that your university has. If we see here that, hey, we were maintaining the student roll number here, as well as we were maintaining the student roll number in the data set for this student, we were maintaining that roll number here. So data set is not in silos. Our data at what particular location has some kind of reference to data at other particular entity, right? Okay. This is known as relations between data. So now we observe one pattern in it, that hey, we are maintaining data about something, and we are also, because we have maintained data about different things, then we somehow need to maintain relations between them. So a database management system which stores data in the form of entities and the relations between them can be known as RDBMS, or Relational Database Management System. Okay. What kind of RDBMSs exist? There are different varieties of RDBMS that exist in the open source industry and are used very widely by different companies. Some of the popular examples can be MySQL, and another popular one can be PostgreSQL. Okay. Now, in these two terms, you would have noticed one thing repeating, right? You would have noticed one thing that was repeating was SQL. What is this SQL? This SQL stands for Structured Query Language. This can be considered as a default language, or I mean, like, it's not actually default, but it's one of the most popular languages to query upon the data that you had stored. Because as we recalled earlier, whatever data that you have stored has also needs to be fetched, right? I mean, like, if data is just stored, it's of no importance to us. It's just increasing your storage. I mean, like, it might be relevant to us in the future, but anyways, at one time we do need to assess it, and that is why we are storing it. Okay, cool. So now SQL, as we told, is basically is the most important language that is used to fetch data from the relation RDBMS systems. Now let us see how SQL works. Okay, so the very first important thing that we see from SQL word itself is a query. What is a query? A query is nothing but a statement that you execute to fetch the data from an RDBMS. What is one important thing about computers? One important thing about computers is they do what you tell them to do, right? But they also require that you should be very well defined. You can't you can't just say random things to it and expect that it will fetch you the exact results that you wanted, right? So you need to be very well defined. So you need to know that how do I write queries in SQL, right? Otherwise you won't get the data that you actually intended to get from the SQL query. So the prime focus for the today's session will be how do we write SQL queries? What are the important constructs that we need to know while we write a SQL query? Most of the SQL functions in different DBMSs are almost same. So that is why we are going to abstract away from one particular technology of a DBMS. We are going to structure about common abstractions that we have in a DBMS management system, and then you can run those over any kind of system that exists. Okay. So the very first type of query, the very first important function or important feature to do a query is the select statement. This select statement is the most important thing that you need to know to run any query. What does select do? I mean, if we just go by the definition of the word, select means selecting something or choosing something from the data that you have, right? So that is the whole function of a select statement. So a very simple select statement can be that, hey, suppose you have a student table and you are maintaining three things about a student. Let us say that he has an ID, he has a first name, he has a last name, okay? And you need to know that, hey, who is the student who has an ID of 1? Suppose that is the thing that you need to know. And there are multiple students. Let us say the student with ID 1 has a first name of A and a last name of P. Then there is a student with ID 2 who has a first name X and last name Y. And you need to know that what is the first name and last name of the student who has ID of 1. So you basically need to know A and P. How will you use the select statement to write this? It's very simple. You will say select. What is this? This is first name. So I need to select the first name. What do I also need to select? I also need to select the last name. So select first name, comma last name. Where do I need to fetch from, right? So suppose someone asks you that, hey, you need to get this thing. I just tell you that, hey, you need to get suppose a biscuit. Where will you get that from? You will ask me that where should I get that from, right? So that information is relevant. So the next thing is from. Where should the query language get the data from? So suppose it gets from a particular table. The name of the table is student. So select first name, comma last name from student table. Okay. If you write just this query, what will you get? I mean, suppose you're a computer and someone tells you that, hey, you have to just get first name and last name from the student table. You don't know. I mean, like you go to the student table and you try to see that which first name and last name I need to get. You see there are a lot of first names and last names. So best way is that you bring all of them, right? If you just write this query, what will it return? It will return the whole table as it is. It will get the first name and last name of all the students. So basically what you will get will be A, B, and XY. Why did it return this? Because you didn't specify which first name and last name should the SQL get, right? Okay, so let us be more precise. Let us say that, hey, you have to select first name and last name from student of the person who had the ID 1. So you need to know that, hey, the ID should be 1 at that place. So you can write where ID is equal to 1. And finally, you can terminate the statement with a semicolon. Okay. So what will this return? This SQL query will return you A and B. And why will it return? This is because of three statements that we just saw here of SQL, that is select, that is from, and that is where. These are the keywords in the SQL query language. Great. So I think the basic idea about a select statement is clear now. Now let us discuss about a subquery. I mean, like we will be discussing multiple of these where clauses from in depth, but let us first discuss the basic high-level concepts before we delve into details. Let us discuss what a subquery is. Now, let us say that you need to give degree to some students. You are a university, you need to give degree to students, right? The students who are just going to pass in this particular year. Okay, now how will you give degree to those students? Suppose you have two tables. The one table that you have is a students table. Okay, in this students table, you have an ID, you have the name of the student, let us say, and let us say that you have batch. Okay, suppose this is a simple student table that you have, and you need to give degrees to the students who are going to pass in batch 2020, let us say. So then someone comes to you that, hey, some of those people who had the batch of 2020 are actually not going to get the degrees because they failed in some courses. Then you ask that, okay, where should I know that which students failed? So that person tells you that, hey, there is also a table that is failed students. In those failed students table, you have IDs of the students who have failed. Okay, so now you need to give degree to those students who have the batch of 2020 but have not failed. So somehow you now need to use what is here to give the result of your final query. How will you do that? To know which are the students who had failed, you need to select all the IDs of students from here, right? So somehow you need to select IDs from failed students. Okay. But the task that is given to you is not to fetch the IDs of failed students. The task that is given to you is to tell who are the students who are going to get the degree. Who are the students who are going to get the degree? Those are the students who actually have the batch, who actually have the batch of 2020 in the students table. So also, you know that you need to do this, that hey, select ID from students where batch is equal to 2020. Okay, so now you need to select those IDs from this students table where the batch was 2020, but you don't need to select those IDs that were present here, right? So what will you do? One very simple way, I mean, like one thing we will come to that in later of section of this video. There is also one statement which can do it in one line. But let us say, you can say that where batch is equal to 2020 and ID should not be an ID not in. And where should the ID not be? The ID should not be in the result of query of this particular thing, right? So ID not in, select ID from failed students, right? So here we saw that, hey, we used one select statement inside another select statements, right? This is also known as a subquery or a nested statement. By the way, this not in is a keyword in SQL where you can select those things that are not present in the result of a particular table as well. Okay, but now let us say that you ask me a question that, hey, how does SQL know that these and these are the same thing, right? I mean, like, how will it know that? I mean, there should be a basic thing that whatever data is here should be whatever the data was present in what was I mean, like, retrieved from the earlier query, right? So that is a constraint that SQL asks you. I mean, like, that's your responsibility to maintain that the data type of the data that is taken from here is equivalent to the data that is here. Okay, so that is what a nested statement is. Okay, now what kind of nested statements can be? There can be two kinds of nested statement. First can be correlated. What does a correlated nested statement means? What does a relation with two things means? Relation between two things means that, hey, one of those things cannot exist without the other thing, right? So a correlated subquery is a query in which none of the, I mean, like, in which this subquery, this is the subquery, right? Subquery is not independent, but needs the main query to execute itself. So it can't exist independent of each other. So if there is a correlated subquery, then what can be a different kind of subquery? The second kind of subquery can be non-correlated subquery. In which the main query, for example, in this particular query, this was the main query and this was the subquery, where main and subqueries are both independent. Okay. What do you guys think was the above subquery? Was it a correlated or was it non-correlated? As we can clearly see that in the above example, the select ID from failed students can exist without even the main query existing, right? So it is definitely an independent or a non-correlated subquery. Okay. Okay, so now we have discussed select, but now you also see that we were doing where, right? We wanted to check about, we wanted to do some kind of assertions that, hey, I need to know data about those things. I need to know the data where a particular thing is maintained, right? So let us discuss the common clauses. This where is known as a clause. Okay. So I mean, like, what is a clause? I'm like, in normal term, in normal real day life, you might have thought about clauses in your agreements or contracts, right? Those are the things that you need to check. Those are the things that you need to ensure. So where is also a clause. So let us discuss SQL clauses. Okay, one of the clauses that we have already discussed is where. There are three other main important clauses. Those clauses are group by, having, and order by. One of the best parts about the SQL query language is that, hey, each of the words in the language are actually very, I mean, like, self-descriptive, right? Because I mean, like, you just see the word and you kind of get an intuition that, okay, what might this thing be doing? What can the where thing be doing? Where clause just allows you to filter the records based upon some conditions. Okay, for example, what were the conditions in the original query that we had written? In the original query that we had written, the condition was that id should be equal to 1. Let us say that our data had multiple students, and those students, let us redraw a student table. In the students table, we again are having id, we are having a name, and let us say we are having batch. Okay, and let us say that there is an id 1, 2, 3, 8, 9, 11, 12. Okay, the name is a, b, c, d, e, f, g, and batch is 2020, 2021, 2020, and 2022. Okay, so now I ask you that, hey, you only need to give me the students who have, the first condition is who are going to pass in 2020, that is, who have their batch as 2020. And the second thing, I also ask you that their IDs should be less than 10. Okay, so then what will your where clause have? Your where clause will have two things. What are those things going to be? Your where clause will have, first will be batch is equal to 2020. And what is the second thing? The second thing that your where clause will have, id is less than or equal to 10. So this is a simple where clause, and a where clause can have multiple things, multiple assertions that need to be maintained. And those assertions can be grouped with and. And if there is and, what do we think that other statement might be? I'm like, just similar to and. Suppose if I'm like, if we have done programming, there is and then there is a or as well, right? So suppose I had, instead of writing and, I had written or. What would the result of this query be? This query will result into all those students who either had a batch of 2020 or had an ID less than or equal to 10. So the query will return this. The query will the query return this or not? The query will return this. Why? Because the ID is less than equal to 10. So this will be returned. This will be returned because this is also satisfied. This is also satisfied. This will be returned because ID is less than equal to 10. This will be returned. This will be returned because batch is 2020, but this won't be returned because neither is batch 2020 or I did this. Okay, great. So that is where clause. Now let us discuss the order by clause. Before we discuss group by and having, because they are interrelated, first let us discuss the order by thing. What do we mean by an order? What do we mean by an order? Order is nothing but an arrangement of things in the way you want them to be arranged, right? Consider order by something similar to sorting. Okay. Now I ask you that, hey, please return me the list of all the students. Okay. I just tell you this thing that, hey, please return me list of all the students. You go, you fetch all the students and you return it to me. But in which order will you return? Did I ever tell you that? No, right? So there might be a thing that you ask that, hey, hi, in which order should I return it? So for example, let us take a normal use case. Suppose there are a lot of things in a restaurant, menu, and those things are grouped by being a starter or being the main course or being a dessert. Okay, suppose a starter is represented by a 1, a main course is represented by a 2, and a dessert is represented by a 3. Okay, now one person asks you that, hey, he has maintained in a DB table, he has maintained one starter, one main course, and one dessert. Okay, suppose he has maintained a DB table which is something like, what will I eat? what to eat. Okay. So which is food ID. It also has food name. Okay. And also it also has food type. Okay. So food ID can be something, I mean, like suppose you are representing breads by something, you are representing some kind of pastries by something like that. Let us say there's a food ID which is 201, which can have a name of pastry, which let us say is a dessert, right? So let us name it 3. Then there can be something he has selected 1. There are multiple things he has selected as main course, so there can be 2 things. Let us say that he has rice and he has some kind of meal or something. Okay. So then there are 100 or 120. And then there is one starter that he selected. Okay, let us say it is XYZ and it has 300. Okay. And this is a starter. So this is 1. In which order will the person like to eat? The person will like to eat in the order that he will have like to have, I mean, like he will have the main meal in between and then the dessert, right? Okay, so you need to, so you just go to the DB table and you say that, okay, return all the meals that the person had selected in what to eat. If you return the meals in the order that exists in the table, then you will actually disappoint the person like anything, right? So you need to return those meals in the order of what type of food they are. So you should return pre-meal here, then you should return main course, and then you should return the dessert, right? So you need to order the meals that you bring by food type. So how will you do this thing? So you will say select food. Let us say you select the food ID. Where should you select those food IDs from? You will select those food IDs from what to eat. From what to eat. Okay. But in what order will you select those? You will select those in order of food type. So you will say order by food type. Okay. So then your SQL query will return this thing first, then one of those 2 things. I'm like, it can return any of those 2 because they have the same food type, and then it will return finally the dessert. Okay, so this is the order by clause. Now let us discuss the other 2 things, having and group by. Okay, what is having and group by? I mean, like, what is the intuition that you guys get that, okay, what might having represent? Okay, so let us first think of group by. But let us first think of group by. Group by is a thing that is used by aggregate functions. Okay, let us actually talk about group by here. Group by is a statement, is a clause that is mostly associated with aggregate functions. Okay, so what does this mean? Aggregate function means that, okay, those functions who actually compute upon a large amount of data and then return a result. So there can be 2 kind of functions, right? One kind of function computes upon a single argument and then returns a value. So those are known as scalar functions, which we will come to in depth again. And then there is an aggregate function. Okay, suppose aggregate function, the examples of aggregate functions can be sum, can be average, and those. Okay, so let us discuss about a simple thing. So let us say that you are using a having clause. So you want to know that you have to return those students, I mean, like, who lived in India and the student ID was greater than 5. Okay, so you need to return count of those. So what you will write? So you can say that select count of student ID, comma, country. So I mean, like, let us say that we had a DB table. In a DB table, with every student, I was also maintaining his country. Let us say in this student table, I had a country of first person was India, then this was USA, this might also be USA, this can be UK, this can be India, and this can be India, and this can be India. Okay, so you need to know that which are the people who have a country of India. So that is the very first thing to know. That, okay, so let us say that we need to know who are the students who don't have country India. Let us say we do the reverse. We need to know who are the students that don't have country as India. Okay, then you get the students. Which will be the students that you will get who don't have country as India? You will get this, you will get this, you will get this. That's it. Okay, but now you need to order them in some way. Someone tells you that, hey, once you have filtered those students who don't have country India, please group all the students that had a country together, right? So group all the students who had country USA together, then group all the students who had country UK together, and so on. Okay, so how will you do that? You will say that select count of student ID, comma, country from students. Okay, where what should be the thing? The thing should be that country is not equal to IN, because IN is representing India. Okay. Okay. Now you get all those students. Now you need to group them by countries, right? You need to group the countries that had USA together. Okay. So group by country. Okay. So all the students that have the same country are now together. That's it. Suppose you return this. What will this return? Now, what a group represents, a group basically creates a single group of people who had the same value here. Okay. So let us decipher this particular query one by one. Okay. In this statement, the very first thing is select from students where country is not equal to India. This thing will give you 2, 3, and 8. So you get these three things. Okay. Then the next thing that you do, you are grouping them by country. So then you get two groups, right? There are two students that had USA and one student that had UK. So now you will get two groups, which are 2B and USA and 3C and USA. And the final one was 8D and UK. Okay. So these two students were in the very first group and this student was in the third group. Okay, now you have grouped them by country. Now what do you need to return? You also need to return the count of student ID. Basically, how many different student IDs were there where in each groups. So because count is a aggregate function. It works upon a different thing. It works upon a set of inputs and returns the number of inputs that are there. So what will be here? It will be 2. What will be here? It will be 1. So what will it return? It will return 2 USA and 1 student from UK. So writing this query helps you to find the number of students from each country where the country is not India. Okay, I hope that is clear. Now let us discuss having. Suppose I have written this query. Okay, and then I tell you that please return only those countries, where the number of students were greater than 1. Okay, so you need to return only USA and not UK. Okay, so having allows you to do filter on aggregate queries, filter on aggregate functions. So you can say that where having the count of student ID. So you can here write having count of student ID, or let us say ID, which is greater than 1. So if you write this thing, you are only going to get USA. So the difference between where is just a filter upon a normal attribute value, whereas having is a filter upon an aggregate function, the value returned by an aggregate function. So the question is why we use having instead of where clause in group by clause. So having actually used to, because see, once you have done group by in function, then you need to do some kind of query upon these groups, right? So consider this as different, that you have done a grouping. Here you have done a grouping, and then out of those groups you are selecting particular groups that had something as this. Okay, so that is why you need to do a having kind of thing. Okay, great. Now we had actually, when I was discussing this particular thing, that hey, let us say that we had to select the students who we were giving degree to. Okay, then I tell you that hey, we also don't need to select the students who actually failed. I told you that hey, we will run one query and then we will run a sub query, and the basically whatever the value was not in the second sub query, we will put in a not in clause and then give, right? This thing can be done in one query in SQL. So let us discuss three functions, which are union, minus, and intersect. Okay. By the way, I'm like, if you have studied set theory, these clauses seem very similar to what we discussed in set theory, right? Is there any kind of relation between set theory and why these terms are like that? Yes, there is. The reason for that is because the relation that RDBMS system, when they were actually originally the paper of RDBMS actually is representing all these things with notations of set theory. So an RDBMS is nothing but a implementation of set theory, that okay, how you will be doing operations upon data in terms of how you do operations upon set. Okay, so each table is actually a set and not order table. So that is why there is no guarantee as to how the data will be arranged in the table. It might happen that this data is somewhere here or this data is somewhere here, because these are sets and not tables. Okay, Acha. Now let us discuss union, minus, and intersect. What is union in a set? What is union in a set? In a set, let us say that we have two sets, A and B. In one set, we have three things, 1, 2, 3. We have four things here, 4, 2, 1, and 5. What is union of A and B? By the way, union in set function is represented by U sign. So what is AUB? This is nothing but 1, 2, 3, 4, and 5. Basically, union is the combination of all the values that is present in any of those two sets, right? If you also notice here that, hey, 1 was present here as well, but 1 was present here as well, right? But in A union B, we got 1 only once. So a union removes duplicates, returns duplicate only once. But what if you want to return, if 1 is present here and here as well, you need to return it twice. What if you want to return 1, 1, 2, 2, 3, 4, and 5? For this thing, there is a union all in SQL. Okay, union all keeps all the duplicates. Okay, so what the union statement basically does is union statements returns all the values that are present in any of the sets. Okay, now what is minus? So I tell you that, hey, I have some things here. I have some things in this particular system, which is, let us say, A, B, C, D, and E. These are some things here. I tell you that you need to return everything that is here, but should not be here. Okay, so what will you return? I mean, like, suppose, let us say that you have 5 things and 2 things. You need to return every of those 5 but those 2, but not those 2. So you do 5 minus 2, right? In maths, you do a 5 minus 2. Similarly, in sets, you can do a set A minus set B. Suppose this is represented by set A, this is represented by set B. If you do set A minus set B, you will get all those queries that are here. I mean, like, they should be here, but they should not be here. Suppose there was an F here as well. So what are the queries that are here? These are A, B, C, D, and E. Okay, and what is the second thing? The second thing is they should not be here. So out of these things, what are the things that are here? So they are B, so B will be removed. Well, that is A, so A will be removed. This is F, but F is not here, so we are fine. And the final return from here will be C, D, E. Now, do you guys think that we could have actually directly used this minus statement in the previous question? What would we have done? Instead of writing where not in, we could have just done minus here, right? So if we were doing here, we could have just done minus here and we would be fine. Correct? Great. So that is the minus query. And then what is intersect? Intersect is also a set function. And intersect between a set A and a set B is represented by an inverted U sign. And it says it returns values present in both set A and set B. So let us say that set A had the values 1, 2, 3, 4, 5, and 6, and set B had the values 2, 4, 6, 8. Now, if you do A intersection B, it will return those values that are present in both of those sets, right? So it will return something that are present here as well as here. So those are things like 2, 4, and 6, right? Great. Now let us actually, I mean, like, now we understand that, okay, what are these commands doing, but how will we actually write them in SQL? How will we use them in a SQL query? In these SQL queries, these statements are between two select statements. So how will it be represented? So one way can be that, hey, select name from students minus select name from failed students. What will this query do? This query will return all those students, the names of all those students that are students but are not failed students. Now I tell you that you need to return everyone who is a member of my university. So suppose my university can have students and he can have employees, okay? And it can also have other things, but let us say that for now these are the only two things, and you need to return everyone who is member of the university community. So now you need to represent a union of those two things, right? Either that person can be a student or that person can be an employee. So what will you do? You will do select name from students union select name from employees. Okay. Now there can be one thing that, hey, I need to select those students. I need to select those students who are actually, let us say, living in a particular city, who are living in Delhi. Okay. Let us say, how will we do that? So we will say select name from students. Okay. Those are all the students, right? And then I have a different table. Let us say my database was arranged like this, that I had a students table and I also had a Delhi students table. Okay. So I need to select all those students that are first of all students. And the second thing that they are also Delhi students, right? So I will do an intersect. I will intersect with select name from Delhi students. So this will return me all the list of people who are present in this set as well as this set. Okay, as I discussed earlier, these terms are actually related to set theory, and an RDBMS is more of like sets and not of more like arrays. Okay, or what is a table. Okay, so these are sets. This is set 1, this is set 2, and this is a set operation of intersect. Okay, so there is a query that is it minus or except. This is a minus. Okay. This depends upon different database management systems as well. Okay, I mean, like, depending upon different DBMS system which are implementing, these concepts might be known by different names, but mostly these are known by the common terminology of union, union all, intersect, and minus. Okay, great. Now let us discuss one of the most important topics that are there in database management systems, that is joins. What is a join basically? Now, as we discussed earlier, that hey, data doesn't appear in silos, right? Some of the data might be here. Also, some information about that student might be in some other table, similarly, and so on, right? Let us say that we are maintaining data about an organization. Okay, let us say that we are maintaining data about an organization. So in the organization table, in the organization data set, we have first thing, we have employee table. And the second thing that we have is, let us say, employee salaries table. Okay. Okay. So now the thing is that I need to know the salary of a particular employee. Okay. I need to know the salaries of particular employee, or I need to return to you. Someone comes to you that, hey, please return me. Let us say that this employee table is storing ID. He's storing the first name. He's storing the last name. And let us say that he's he's storing the role. So these are the 4 informations that are maintained in an employee table. And let us say the employee salaries is nothing but an ID and there is a salary. Okay. Now someone comes to you that, hey, please give me the list of all the employees along with their salaries. So now what you need to do is you need to return some data from here along with some data from here, right? So you need to return a group of things. So suppose there was an ID 1, the first name was A, the second name was B, his role was, let us say, he is a CEO, and then the salary of ID 1 is, let us say, 10,000 some units. Okay. Then there is an ID 2, first name is A. 2 people can have the same first name, right? The last name can be C, and let us say his role is a VP. The salary of VP is something like, let us say, 8,000, and so on. And what you need to return? You need to return 1 A, B, CEO, and 10,000, 2 A, C, VP, and 8,000. So now you see that, hey, to return my answer, I need to actually fetch 2 tables. I need to fetch data from 2 tables. Okay, but how will you ensure that this data corresponds to this data, and this particular row, this particular record corresponds to this particular record? How did you come to know that? You came to know that based upon the ID here and ID here. You joined, or basically you selected those, you combined by the ID. Where this ID matched, you combined those, right? This is the use of joins. It allows you to fetch data from 2 different sources, from 2 different tables, based upon something that matches. Okay, so now how is this happening? Let us discuss different type of joins when this will become clear. So the very first join and the most important join is the inner join. Inner join allows you to basically join based upon a particular column, and the data should be present in both of those things. So suppose there was a ID 3 and he had a salary of 6,000, but you don't see any employee with ID 3 here. So what is even the use of returning this data, right? So I mean, like, if still the same person asks you to return all the employees along with their salaries, you only need to return this, correct? Because you don't know if this 3 person is here. And let us say that there was an ID 5 and his first name was D, his last name was E, and he was also a VP, but you don't have his salary information. So you don't have his salary information. There is no salary information available here. So you only need to return those data whose information is available here as well as here, right? So this is the concept of an inner join. Okay, so let us discuss that how this inner join is going to work. So this is going to, I mean, like, the normal function, how do you write is that select star from first table. By the way, what is this select star doing? This select star does nothing but returns all columns of the table, all columns, okay, not the rows. Okay, so we select star from table A, and then when we have selected everything, so basically I have selected everything from this table, then I also need to select everything from the employee salaries table, right? So then I will also select star from table B. Okay, but I need to join them. I need to join this with the second thing, right? How will I join this? I will see that, hey, ID here matches the ID here, right? So what I can do is, rather than doing this, so I say select star from table A, I select everything from the first table, and I join with what? I join with table B. That's it. This is equivalent to select star from table A, inner join table B. So writing inner join is normally in most of the DBMS is not mandatory. Okay. So when you have done this, you get the result of this based upon these two tables. Why? How it automatically selects that what should I group by? It sees that, hey, there was an ID column here, there was an ID column here, as well as there was an ID column here. Because both of those columns had the same name, so it makes sense to, I mean, like, it makes sense to choose that as the common name and then group by that, okay, and then join by that. So that is the inner join. That is the most common join that is used. The second type of join is left join. This is a left outer join, but let us call it left join. What it says is select everything from left side, and if corresponding values are not there on the right side, fill those values with null. Let us take the above case. So suppose instead of doing an inner join where the value was present in left side as well as in the right side, I was doing a left join upon this table. So what would I be returning? So I will definitely be returning everything which was from the left side. So I will be returning 1, I will be returning 2, I will be returning 5. But there is no corresponding data for row 5 on the right side. So for those particular things, for all those values of this thing, I will put null and null in the salary. So what will I be returning? I will be returning 1 who has a first name of A, B, CEO, and his salary is of, let us say, 10,000. I will be returning 2, A, C, VP, who has a salary of 8,000. I will also be returning this because this is a left join. So I will be returning 5, D, E, VP, but I don't have any information about this, so I will replace this by null. So this is the left join. As there is a left join, so obviously the opposite also has to be true. So the opposite is right join. What this right join means? This right join means select everything from the right side. Now you have to do the first selection on everything that is on the right side. Now, if the corresponding data of the similar column is not available on the left side, fill the left side with null. Okay, fill the left side with null. If corresponding data is not available on the left side, fill the left side with null. So what will it return? It will return 1, it will return 2, it will return 3. For 1 and 2, there is the data on the left side, but not for 3. So what I will be returning will be 1, 2, and 3 are the IDs. For one, I know the first name, I know the last name, I know the role. So this is CEO, and I also know his salary. Okay. For two, I also know everything. So I know that his name is A, his surname is C, it is a VP, and it is 8,000. But there is a person 3 whose first name and last name I don't know. So what will I return? I will return I will return null, 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 and 6,000. So this is a right join. Okay, so we have done left join, we have done right join. What can be other thing? The other thing can be, if there is, select everything from the left side, select everything from the right side. If left side has corresponding data in right side, obviously do the join. But if there is no data on the right side, fill with null. Similarly, if there is something on the right side which doesn't have a corresponding data on the left side, fill that with null. So it's a combination of left join plus right join. And what will it return? It will return, and I'm like, it's known as a full join as well. Full join. Select everything, join if a match, else fill left side or right side by null, depending upon the situation. So let us see what will be the full join output for this particular table. I will be returning everything from the left side, right? So I will be returning 1, I will be returning 2, I will be returning 5. So it will definitely be returning at least these 3 things. Okay. But I will also be returning 3. So I will also be returning 3 because it is present on the right side, but it is not present on the left side. So I will also be representing this thing. So if you see, this is the output of left, this is the output of right. What is the output of a full join? Output of a full join is nothing but union of left and right, right? So basically, what will be the output of a full join? It will be 1 A, B, CEO, who has a salary of 10,000. Then there is 2 A, C, VP, who has a salary of 8,000. Then there will also be 5, whose name is D, E. Then he's a VP, but I don't know his salary. But I am also doing a right join, so I will also be returning this. So it will be 3, null, 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 and I know his salary is 6,000. So this will be the output of a full join. Now there is one more thing that that is also there. That is a cross join. So let us say that we have 2 sets. Basically, each select query is nothing but a set, right? So we have a set A and we have a set B. And there are multiple values here. Let us say they are A. These are different rows, right? So these are A, B, C, D. These are, let us say, F, G, and H. Okay. If we have 2 things, if we have 2 different sets, and you have to make a Cartesian product or a cross product, Cartesian or cross product. Okay. What this means is that, hey, combine all the values from the left side with all the values of right side. So basically, what will be the final output? There will be this one row, these. So there are 3 rows. Similarly, there are 3 rows from here. There are 3 rows from here. And similarly, 3 rows from the final D. If there are 4 values in the left side and 3 values in the right side, how many values will be there in the final set of the cross join? If it is a cross join and one side has 4 values and the right side has 3 values, the final values will be nothing but 4 multiplied by 3. Why? Because each row on the left side is going to produce 3 rows, because it is going to be combined with every value on the right side and thus produce 3 rows each of those. So we will be getting 4 into 3, which is 12 as the final table. Okay. So there's a question that what if there are more than 2 tables? If there are more than 2 tables, you can use just parentheses to say in which order do you need to find the outcome. Okay. And all these functions are actually commutative. I mean, like union and intersection functions are commutative. So any of those order works. Suppose you have to do intersection of 3 sets. Okay. So then you can do select star from A. Then you can do union, select star from, let us say, B. Now, whatever all these values we got from here, then we need to do intersect, select star from C. So we can put this in parentheses so that this is executed first, then an intersection with this thing will be executed, and there will be an outer parenthesis as well. So I mean, like, we can group those statements together as we want them to. Okay, great. Now we have been discussing a lot different kind of joins, but what are we actually working upon? We are actually working upon the data. We are actually working upon getting the data. Suppose you have the data, what is your main idea? Like, you want to get that data as fast as you want to, right? I mean, like, you want that, hey, please get me the data as soon as you can. Okay, so you need to ensure that my queries should run fast. How will you make the queries run fast? I think everyone must have heard about arrays, right? Everyone must have heard about arrays, and you guys would have also heard about hash maps. What is the difference between searching a value in an array and searching a value in a hash map? Searching in an array is a linear time operation, whereas searching, I mean, like, if the array is not sorted, and searching in a hash map is probabilistic order of 1, right? Okay, so what we observed from here was that, hey, in a hash map, we use some kind of different space or some other optimization or some other conversions to improve our search time complexity, right? Yeah. So if we want to optimize, if we want to speed up our queries, we can probably use some other memory. We can use some memory to speed up our queries. Okay. Using some memory to speed up queries is known as indexing. Okay. Now let us say that you know that, hey, a lot of times I need to find all those students who had total score greater than 80. So suppose you have a table, suppose you have a student table in which there is an ID, there is a name, and there is a total score. Again, recall that, hey, SQL is not a array. SQL is a set. Okay, and there is no order in a set. A set can be returned in any random order. So suppose there is an ID student here who has a name A and whose score is 60. Then there can be 2 whose name is B, whose score is 10. Then there is a 3 whose score is 90, and let us say his name is C. Then there is 4 whose also name is A. It can happen that 2 people have the same name. Then it's also 80. Then there is 5 whose name is L, let us say, and his score is 5. Okay, now always there are a lot of queries that come that, okay, each query you have is that, hey, find all the users or find total number of users who had sum or who had score greater than equal to X. If it was an array, I mean, like, if suppose this was the final data set that you had, and you knew that you are getting a lot of function calls just finding score greater than equal to X, would you like this data to be arranged in some kind of order? You would like that, hey, this data, if this data is sorted by the total score, right? If this data is sorted by total score, then you can answer each of these queries using binary search in order of log n, right? So you need to do some kind of post processing. Okay, and also you need to know what are the common operations that your database has, or what are the common queries that your database has. So this is known as a database indexing. What is an index? First of all, an index is nothing but a data structure. To study which is a data structure that actually does that is not the scope of today's lecture, but if you want to study that, you should definitely see about that B tree and B plus trees. What are these? So this is how indexes are actually, I mean, like, most of the times implemented. So an index is nothing but a data structure that provides quick lookup. Okay, because you need to arrange the data. I mean, like, hash table is also nothing but a data set, right? So quick lookup based upon a query, based upon queries in a column or a set of columns. What do I mean by set of columns? Why set of columns? Okay, sometimes it can happen that, hey, suppose a lot of times that you have queries that are actually not just based upon a particular column, but are based upon a conjunction of multiple columns, right? That all the students who have a name beginning with, let us say, B, and who had a score of less than equal to 80. Okay, so then you probably need an index upon 2 columns, which can be name, and the second thing can be total score. So How to choose which will be the columns that you will index upon, that depends upon what your application is showing. What data is your application assessing a lot of times? If you see that a particular data is being assessed a lot of times, it makes total sense to add an index over those particular columns. How will you create an index, by the way? To create an index in SQL, you run this. So you run a statement like this, create. So by the way, I mean, like, if you ever have to create something in SQL, you use the create statement. If you have to create a table, you use this. You have to create a database, you use this. In this time, you have to create an index. So you do create index. You can also name the index. Okay, I mean, like, you can call the name of index, something that you want to do. So let us say that I call this index name score. So I create an index whose name is name score. Then I also need to specify what are the columns that I'm creating that index upon. So I'm creating that index upon columns that are name and total score. But these columns can be present on a large number of tables, right? These columns can be present in a lot of tables. How to decide that which is the table I'm talking about? So I also need to mention the table. So I will say on students, name and total score. So if I run this particular query, it will create an index upon these two things. What is the disadvantage of an index though? The disadvantage of an index is that it needs extra space, but that is fine. An extra space is not a big issue, but it can slow down writes. So let us say that, okay, let us say we don't know about B trees or B plus trees, but you had to actually implement an index yourself. Okay, if you had to implement an index yourself on this particular thing, you can say that, okay, I will always maintain this table in sorted order of table score. And then if insertions happen on this particular table, what will be the time taken to insert? It will be linear, right? So I'm like, because you always need to ensure that the table is sorted, so then you can't do it in order of one or in constant time. So indexes can slow down writes because they need to process the new data that it achieved. Okay, that is an issue with indexes, but otherwise they are actually always beneficial. Okay, great. Now, what kind of indexes can be there? The indexes can be of two types. There are two ways in which you can classify indexes. The very first way in which you can classify indexes is unique and non-unique index. What does unique index says? Unique index basically allows you to maintain that if a particular data is if there is a duplicate in a particular column or in a particular set of columns of the data. Suppose you have a data in which you want to always ensure that no two students have the same name. No two students have the same name. How can you do that? To do this thing, you can create a unique index on name column of students, right? So what will happen is that at any write, whenever a write happens, it will check the index if a constraint that was set in any of the index is being broken or not. Okay, if we had not indexed this thing, checking this would have been a more complex operation or a more computationally expensive operation. But as we have maintained an index over that particular column, it immediately allows me to check that if that constraint of uniqueness is being broken or not. Okay, so unique indexes are there to ensure some constraints in there. Then what is the definition? Why is there a need of non-unique indexes? Non-unique indexes exist to speed up the query. So while unique indexes, the main purpose of unique indexes is to maintain the constraints or data integrity, right? They need to ensure that the data integrity is maintained, but the function of non-unique indexes is only to speed up the queries. Okay, and that is the biggest advantage that non-unique indexes have. Okay, now there is also another way in which we can classify the indexes. This way is known as clustered and non-clustered indexes. Okay, the very first thing that I told you was that, hey, a relational database is not a table, but it's a set. Okay, so that means there is no definite order in which the data would actually be stored in memory, right? It could be stored in any way. Okay, now if I tell you that my query is always to select people in order of their roll numbers. If I say that I have a student table again, okay, I have their roll number, and let us say that I have their name. And I tell you that my queries are always going to be selecting students in the order of their roll numbers. But as the databases are set, so the roll numbers can be arranged in any order. So 3 can be here, 2 can be here, 4 can be here, and like this, name is A, name is B, name is D, let us say name is C. Okay, so data can be arranged in this order, but I tell you my queries fetch students always in order of roll numbers. Now, what would you like to have? I'm like, will there be something that makes immediate sense that, hey, if my queries are always fetching data in the order of roll numbers, should I arrange my data in the order of roll numbers? If I have arranged my data in the memory in the order of roll numbers, it will speed up my queries, right? Because then I need to just iterate over the data and I'm done. Okay. So what clustered indexes allow you? Clustered indexes, they change the way data is stored in the database as per the index. So if I create a clustered index based upon roll number, what will it basically do? Inside the memory, inside the storage where the data is actually stored, this will change to 1, 2, 3, 4, and 1 has C, 2 has B, 3 has A, and 4 has D. So now, if my queries are always in the order of roll numbers, they will become very fast. Okay. So that is what clustered indexes are. But what are non-clustered indexes? Non-clustered indexes maintain a separate data structure to optimize queries. Let us just see only this definition of clustered indexes. If clustered indexes change the way in which data is stored in the memory, can I have more than one clustered index? No, right? Because if I have more than one clustered index, then I need to store the data inside the memory as per the conditions of two indexes, which is not possible, right? Because there can be only one way in which I can dictate the order the data has to be stored in the storage, right? Okay. So one issue with the, or basically one thing with the clustered indexes is, the very first thing is that there can be only one clustered index, while there can be multiple non-clustered indexes. Okay. The second difference between clustered and non-clustered index can be that the clustered index changes the order. Clustered index affects how data is stored in memory, while non-clustered indexes don't. Okay. 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 Let us say that we have these two things. If we have a clustered index upon a particular column, and also if we have a non-clustered index upon a particular column, which of those do you think will be faster? If we have a clustered index, basically because clustered index is actually directly affecting the data set, right? And it is storing the data in the way you are assessing. Also, you have a non-clustered data set. Which of those do you think will be speeding up the queries more? Obviously, the clustered index will have even faster queries, right? Clustered indexes have faster performance with respect to non-clustered. Okay. Because in a non-clustered index, you actually first talk with a different data structure, and then that data structure depicts that, okay, now fetch this data, now fetch this data. Whereas in a clustered index, the data itself is stored in that manner, and thus it helps you to speed up those queries. Okay, great. Now let us actually talk about something called as views. What are views? What a view is, let us say that I need to have one source of truth. Okay, so I say that there is always one source of truth, and a lot of times I'm storing data about students again, let us say, and I am also storing their gender. I have students, suppose I have their ID, I have their name, I have their batch, and I have their gender. Okay. Okay, so let us just write few things. A 2020, gender can be male. 2, which can be B, which is 2020, gender can be female. And 3 can be A, let us say C, whose batch is 2018, who can be, let us say, again female. And 4 can be T, 2019, can be male. Okay. Okay, so this is the data that we have. Okay. Now, what I tell you that there is one person in my university who ensures that whose job is to ensure to do data analysis upon the data of females. Okay. Suppose her job is that, okay, let me actually analyze the data of females, do some operations with it, try to find out some information from it. Okay. How can I ensure that the repeated task of that particular employee in my company, whose task is only to just do multiple queries upon the data of females? Okay, so this is students. Then one way can be that I create another female students table. So one can be that I create another female students table, and that female students table will be like this: name, batch, gender, and then there will be 2B 2020 female, then there can be 3C 2018 and female. That is one way in which you can do that. Do you guys realize that there is some issue with this? There is some issue in which the data is being arranged here. The issue with that is, now if a new student gets added, suppose there is a new student that gets added whose ID is, let us say, 5, name is E, batch is, let us say, 2019, and she is also a female. Now we don't just need to put the data here, but we also need to put this data here. Okay. And if by mistake you forget to put this particular data at this side, then the employee whose job was to ensure the data, to do some operations or analysis over the female data, will go wrong. Okay. So what would you ideally like to have? You would ideally like to give the employee who is working on the female data a view, a subset view over the students data, right? That, hey, he can see what is the data of students, but only that subset of the data of students where the gender was female, right? That makes sense. How can we do that? We can do that by creating a view. So a view is nothing but a select statement, that gives an intuition of a different table, while in reality data is present only at one location. Let us see how this works. Like, suppose we have this data only, then what will a view do? A view will actually, let us say that this is, it kind of like is a camera over that thing, that, okay, it allows you to see this thing but with a filter. It allows you to see this thing but with a filter. So here, this view is, let us say that the female students is no longer a table, but female students is a view. This view behind the scene is just running a select query, which is just selecting those students from the students table that have gender as female. But the employee whose task was to work upon female students can now use it as she would have instead used a female students table. That is what a view does. So view basic. And now what would happen? Now if you ever do a write here, now if you add a new thing, you just need to add it here. As soon as you add it here, this view will automatically get updated because there is only one single source of truth. Okay, awesome. Now let us discuss some of the how can we do the where clause? Okay, we have a where clause, right, that we have discussed. One way in which we have used the where clause till now is using equal to's, right? Using directly checking for equality or checking for less than equal to and all those things. Let us discuss something called as wildcard patterns and other things that you can use in the where clause. Okay, so where clause, let us say pattern matching. Okay, so in where clause pattern matching, let us discuss different kind of things that can happen. The very first thing is wildcard patterns. Suppose a complaint comes to you about a person, and the person who actually did the complaint didn't know the exact name of the person who did the crime. Okay, and then what he tells you that I just know one thing, that, hey, his name starts with KH. That's the only thing that you know. Now you can't just do a DB query. You can't just do a SQL query where name is equal to KH, something like that, right? So you would like the name. So you want to do a SQL query where name starts with KH. Okay, how can you write such query in SQL? In SQL, you can have pattern like K percentage. What KH percentage means? This means KH and followed by any sequence of characters. This can represent KH, This can also represent KHA. This can also represent KHAY, and similarly, right? Great. So this is what a percentage or a wildcard pattern is. So how will you use this wildcard pattern? Suppose the task that is given to you is find all students whose name begins with KH. Okay, suppose this is what the data that is, the question that is given to you. And the data set is something like this. This is the student table. And in this student table, you have an ID, you have the name, and you have, let us say, batch. That should suffice. So there is a student with ID 1 whose name is Khyati, and the batch is 2016. Then there is student name number 2 whose name is, let us say, Aman, and whose batch is also 27, let us say 2017. Then there is student 2 who is Khayal, let us say, that might also happen. Then his batch is 2016. You need to find all the students, and let us say that there is also one more whose name is Kamal. Now, what will this query do? So we need to find all those students whose name starts with KH, right? Whose name starts with KH. So that means we need to return this, we need to return this, and that's it. Okay, we don't need to return this because this starts with KA. So what SQL provides you? The SQL provides you first the wildcard pattern, and the second thing is a like statement, is a like keyword. So you can write thing like that here, select star from students where name. See, when we actually know the exact name, we use the equal to sign, right? But now we don't know the exact name. So instead of equal to sign, we have to use like, where name like, and then I will say KH percentage. I hope that is clear. Okay. Now, rather than finding all the students whose name is KH, I tell you that, hey, the question is changed, but I need to find all those students in between their names. Suppose AMA is coming. Suppose I need to find all the students that have AMA in their name. Anywhere in their name. I mean, like, it might not be the starting characters, it might not be the ending characters. What can be a real world use case? Suppose what do we say that, okay, I mean, like, an examination is going on, and the invigilator finds a chit, and the invigilator finds a chit. On that chit, the name of a person was written. It was AMA. Now the invigilator wants to know who might be the students, who would have done, whose chit that might be. Okay, so now you need to find all those students that had AMA in their name. How can we do that? To find all those students that had AMA anywhere in the name, we can write percentage AMA percentage. So what this percentage symbol is representing, basically, if we see from this particular thing and from this particular thing, is any sequence of 0 or more characters. Okay, so this percentage AMA will match Aman. This will also match Naman, but this won't match Amit. Okay, so what can we do? We can just write a statement, select star from students, where here we wrote where name like this. So here we can write where name like percentage AMA. Now, we had also discussed a thing like, I mean, like, in the very beginning of this video, that if we want to remove a subset of the queries from my statement, right? So I had used a not keyword, right? What this not keyword allows you to do, this not keyword allows you to omit those results present in something else. So let us say that my just query just changed. I somehow know that, okay, the person who had did this, I mean, the person who did this thing, his name just doesn't have AMA. That's the only thing that I know. Okay, then what can I mean, like, how can I find all those students that had, how can I find all those students that didn't have AMA in their name? I have to find all those students that didn't have AMA in their name. I can just use this not keyword. I can say select star from students where name. First we were doing where name like. Now we don't want the name to be like some things, right? So we can say where name not like percentage AMA percentage. So if we run this query, if you run this query, this will return Amit, but this won't return Aman. Okay, now we have discussed three things. We have discussed percentage at multiple places. We have also discussed not. There is also a specific sign, okay, a wildcard for a specific position. That is nothing but the underscore sign. Okay, what it says, suppose I want you to find all those people, all those students, the third character in whose name was, let us say, M. Okay, so if I only want you to find all those students, the third character whose name was M, but anything else can be anything else. Okay, so I want to return Naman, and I want to say, let us say that there is something called Lambot. I need to return this as well. I need to return this as well, but I don't need to return Amit. Okay, suppose this is what I want to return. Okay, so how can I do that? I know that the first two characters can be anything. Then there should be an M. Then there can be any number of remaining characters. Okay, if I write percentage M percentage, will this work? No, this won't work. Why will this not work? Because this will also return Amit. Because Amit also satisfies percentage, M, and all this as percentage. So what can I do? I can say that the first two characters should be underscore. So underscore matches any character, any single character. Okay, so first two characters should be underscore, then there should be an M, then there should be percentage. What this means is that the first two characters, so that numeric value, that there should be a percentage, then there should be an M, that should be a percentage, that is fixed. So I can find all those students who had the third character as M by something like select star from students where name like slash underscore underscore M percentage. Okay. Now let us talk of another question. Let us talk of a question where I had to return all those students whose name had more than 4 characters. I had to return all those students whose name had more than 4 characters. How can you do that? If the name has to have more than 4 characters, we know that the first 3 characters can be anything. The first 4 characters can be anything. So we can just write that by underscore, 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 underscore. That means the first 4 characters can be anything. Then it can be percentage. There can be any number of characters after this. So a query to select all those students who had name greater than 4 characters can be something like select star from students where name like underscore 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 and percentage. Okay, so that was in wildcard pattern searching of strings in a database. Let us also talk about what kind of database, like what kind of operations can actually have can happen on a database. Because if you are using a database management system, you need to know what are your requirements, right? What kind of data that you want to have, okay, or what kind of operations happen, or what kind of requirements are there from the data set, so that you can choose a database system that actually conforms to those requirements. So there can be two kinds of database management systems that are commonly known. The first type of database management systems are OLTP, and the second thing is OLAP. So how to distinguish between these two? You can distinguish between these two types of data sets using the word T and A. Okay, what does T means? T means transactional. What does A means? A means analytics. Let us try to understand the difference between OLTP and OLAP. So as we see from the name that OLTP database is more for transactional things. Okay, what do we mean by transactional things? Transactional thing is a large number of queries, but each query is very small. Okay, like let us say that very simple thing. Let us say that I just need to select all those. I just need to increment the value of something by 1, or let us say that I still have the students table and I have their marks as well. Let us say, so I have students tables, I have their marks, and let us say the student table has something like this: ID, comma name, comma marks. Okay, so there is ID 1, A, initially his marks are 20, then 2, B, 30, something like this. Okay, so now my queries are things like, hey, insert a value or update a value, things like that. These are very small operations, but these operations are happening a lot of times. In those scenarios, you need a transactional database management system. So what that transactional database management system will need to do, it should have actually a very fast response time. You will be very sad if just to create a like, if just to submit a like, it takes a lot of time for the Facebook's database system to actually store that like in the DB and return you that, okay, you have liked that post. Okay, let me actually just tell the full form of these things. OL stands for online and P stands for processing. So online transactional processing and online analytical processing. Okay, so this is the difference between OLTP and OLAP. Okay, so in an OLTP database, I need fast response time. Okay, so my CPU requirements are not that much, but I need to be able to serve a lot of requests in very fast. Okay, so normally OLTP databases are actually distributed. Okay, because you need to serve a lot of requests, a lot of parallel requests, which are normally short. So you actually distribute your load. Whenever you actually have to have a lot of small queries, the best way is that you distribute those things and have multiple different computers handle it rather than having a vertical scaling approach. Okay. Whereas, consider you are a company, consider you have a database of a lot of users being stored since long. Okay. And then every 2 months or every 1 month, at the end meeting, you do a very big processing over those database. You try to find all those users who had posted more than X messages, or you find all those students who had actually attended more than 5 classes, and then who had actually also solved more than X contests and solved those things. Okay, so in online analytical processing, these databases are useful for business analytics and intelligence. Smaller number of queries happen, but each query is quite complex, can be quite complex, we will say. Okay, because I mean, like, one query might be fetching from a lot of tables and doing a join between them and trying to find a lot of other things. Also, in OLAP database management systems, other things that are actually, I mean, like, if you're doing a business intelligence, visualization becomes very important, right? So visualization, etc., are common features. Okay, so in this thing, being distributed is one important aspect, but in this thing, having a large support for visualizations and other things is a more important task. Okay, now let us actually talk about a very important thing in database design. I mean, like, how will you even create I mean, like, how did we decide that what tables do we need to create, or what do we need to store in what table? How did we decide that? Let us discuss this. Actually, this is a very I mean, like, important topic as in terms of database management systems, in terms of understanding database management systems. This is normalization. Normalization allows you to have good database design. Good database design in terms of what? In terms of how we are arranging entities and relationships between them. Okay, so normalization also allows you to reduce data redundancy. Okay, let us say I had the student table again. In the student table, now I'm also storing the address of everyone. I'm also storing the address of everyone. Okay, so let us say that student has ID, he has a name, he has a city where he lives, he has a pin code, and these are the things that I need to store. Okay, so let us say that this is the database. So let us say that we have ID1, his name is A, he lives in Delhi, and his pin code does not live in Delhi because Delhi has multiple pin codes. Let us say he lives in a city XYZ that has only one pin code, and let us say that the pin code is 110001. Then let us say that there's a student 2 whose name is B, who lives in city ABC, and the pin code is 133001. Then there's a student 3 who also lives in city, like, whose name is C, who also lives in city XYZ, and the name is 110001. Okay, suppose after a few days, government decides that, okay, we will be changing the pin code of the city XYZ. What can happen? What can be an issue in this database design, in this database schema design? The issue can happen is that, hey, suppose government says that the city with XYZ will now have a pin code of 127201. Suppose this is the pin code that the new pin code of XYZ has to be. Now, if this happens, what you will have to do is you will have to go on this student table Everywhere where 110001 is there, you have to change 1 to 7201, you have to change 1 to 7201, and all those things, which is a very bad design, right? What can also happen is that suppose there was also another student C, let us say G, he lived in city XYZ and had a pin code of 11001, but you somehow forgot to change this. And that's a bad thing for you. Now your data at some places is storing the pin code 127201 for the city XYZ, but at some places it is storing 111001. That means the data is not consistent. What do we mean by that? We mean irregularities in the information. So what would you ideally like to have? You would ideally like to have is that, hey, all these cities, I mean, like the city and pin code, because a city can be recognized just by the pin code, right? So I would ideally like to have is that somewhere I'm maintaining the pin code and the city name. If I am somewhere maintaining the pin code and the city name, I can ensure that these consistency issues are reduced to minimum, right? So what will be very good for me is that let me have a ID, name, and pin code here, or let us say instead of having one table storing this, I can have a student table that only stores ID, that stores name, and that stores city ID, right? And I have another table which is city table that is storing city ID, city name, and pin code. Now we have 1A and let us say 1 here. Also we have 3C and 1. We have 4D and 1. Now we have 2B and 2, let us say. So we can say that the city ID 1 has name XYZ and has a pin code of 111001. City ID 2 has name ABC and 133001. So now if government decides to make the change, you only need to make one change, that is here. And this thing will automatically conform to new changes that happened here, right? So this is the advantage that you get by making your designs of databases very good. Okay, so these are known as normalized databases. Okay, but how will you decide that there is a need to improve the database design? Let us discuss normal forms for that. There are 6 normal forms actually, but greater than 3 normal forms are not actually used much. So we will be discussing here 1NF, 2NF, because those are more prominent. Let us discuss what 1NF says. A 1NF a table or a database schema design is known to be satisfying 1NF if there are no multi-valued attributes. What do we mean by no multi-valued attributes? Suppose you have a library management system, and in a library management system, you store which books have been allocated to a particular student. So you need to have a table, let us say allocation table, in which you have a student ID and you have a list of books. Okay, so suppose there is a student whose ID is 1 and he had bought and he had rented, let us say 5 books. So those books had ID 101, 120, 113, 120, and let us say 121, and let us say 180. Okay, so there can be a student 2 who has rented 3 books, let us say 11, 113, and 21. So on. This database schema design in which any of the table can have more than one rows is, in which any of the column can have multi-valued attributes, because this attribute has multiple values. This is not just a single value. This is not just an atomic value. So this does not satisfy 1NF. So how will we convert this data into 1NF form? We can change this data into 1NF form by splitting this data. Like this. Student ID and books, and say 1, he has 101, 1, 120, 1, 113, 1, 121, and 1, 180. Similarly, 2 has 11, 2 has 113, and 2 has 21. Okay, this data, this satisfies 1NF, this does not satisfy 1NF. Okay, so that is how you convert a data set that is not satisfying 1NF into a data set into a schema design that satisfies one normal form. Let us discuss about second normal form as well. 2NF data, I mean, like the exact theoretical definition of this is that there should not be any column, or a set of columns that can be uniquely identified, by anything other than the primary key or the candidate keys. I mean, like, what are the primary keys and what are the candidate keys? We will discuss in a moment. But let us take care of this thing. Let us see the example that we had here. Let us see the example we had here. What was the primary key of this table? Let us firstly define primary key as a row, as a column value that has to be unique. For any record in the table. So, for example, if we see, the ID has to be unique. I mean, like, no two students can have the same ID. That is the main source of distinguishing between any two records. Okay. So what it says is that, let us see this pin code and this city thing. Do we think here that pin code actually doesn't need this ID to be uniquely identified? Pin code can be uniquely identified if we just know the city. But city is not the primary key, right? I mean, like, pin code can be identified by the city, but city is not the primary key. That means there is a subset of columns in my schema design that can be uniquely identified without even the primary key, which is ID. So how can I convert this data set into second normal form is what we just did here. But the conversion that we had done here was nothing but the conversion of a data set that does not comply with second normal form into a data set that complies with the second normal form. Let us actually take one more example. In which we can do that. Okay. Suppose, let us say that this example is actually present also on the interview practice forum of this. So what it says is that, let us say we have a students table. We know the student ID, we know their name, and we also know if he's a Mr. or if he's a Mrs. Okay. Then we say that, okay, let us say that we have students, we have ID, we have name, we have gender, and we say that what is the salutation that we use for them. Okay. So let us say that salutation can only be Mr., Miss, or let us say it can be doctor. Okay, these are the three salutations that are allowed. Okay, can we somehow know these three things by some other thing? I mean, like, let us say that currently I'm maintaining students like this. One whose name is A, whose gender is, let us say for now we have only Mr. and Miss. Okay, we name it A and gender is male. We have student B whose gender is female. We have student 3 whose gender is A, whose name is B. This salutation will always be Mr., this will be Mr., and this will be Miss, right? But actually what we realize here is that, if we just know the gender, we actually know the salutation. So what happens if I suddenly decide that I will call all the males not Mr. but suppose Master? I might decide that. Then I will have to iterate over the students table. and update this and that can lead to consistency issues. So this is where, I mean, like, if these are the two columns that can be uniquely identified by something other than the primary key, we split these set of columns into a different table. So we split this by only maintaining gender here. So let us say that we are maintaining ID, name, and we are maintaining gender ID. Okay, so we are saying 1, 2, 3, he is A, he is B, he is A, then gender is 1, 2, 1. Then based upon gender ID, I can store the name. I can also know the salutation. So I can say that gender ID 1 is male and the salutation is Mr. and the gender ID 2 is female and the salutation is Miss. So this is how I convert a table or convert a schema design that's not into the second normal form into something that is a second normal form compliant. Okay, great. Now let us discuss one last thing before we actually end the today's lecture, is something called as procedures. Okay, something called as procedures. In normal functions, when you would have, I mean, like, in normal programming that we do, we don't just write code sequentially, right? We don't write code sequentially, but we actually make our schema design procedural. right? We say we have a function called print this, we have a function called do specific task to ensure that a SQL code, that means our normal program is modular. Okay, that should look modular. Okay, how can we do the same thing in SQL? In SQL, we have something called procedures. Procedures are nothing but select statements. They are also select statements that can be identified by a function call. We can create procedures, and each procedure is doing nothing but a select statement. Okay, so each procedure is doing nothing but a select statement. They are select statements that are identified by the name. Now, these procedures can be something that also manipulate the data, right? They can actually change the data as well, that whatever is in the data set at that particular location. So suppose there can be a procedure, or this can be update statements, modification statements. Okay. So example, the one example for that can be, suppose this was the thing that happened, that hey, you decided to call all mails master. Okay, suppose you decided to call all the mails master. Now what you will do, you can write a procedure, which is called change salutation. It can take in gender, and it can take in new salutation, right? And then this recursively runs the SQL query and then changes it. Okay, now when we are actually discussing this, let us actually discuss what kind of SQL statements we had, that we had. And let us actually parallelize its intuition with how you build a house. When you are building a house, what are the things that you need to do? Okay, I mean, like when you are building a house, first you need to decide that, okay, how will my house look like, right? How will my house look like? So that is basically definition. Okay. Then the second thing can be who will live in the house, right? Who will live in the house? Okay. What can be the other things? The other thing can be you put something in there, right? You actually put some value there or put some data here and all those things, right? So the other type of queries can be that, hey, you manipulate or you change the design, that you say that, okay, I will put one more thing in the kitchen, or I will do these things. Okay. So those can be what we say controlling it, or we can say it as modifying it or manipulating it. Okay. And what can be the fourth kind of thing? The fourth kind of thing can be that, hey, you have manipulated, you have queried, you have you have defined the thing, you have queried, you have manipulated. You also say that who is going to control the thing, who has what access. So these are the four things that are actually in SQL, these are the four kind of statements that exist. The very first kind of can be data definition language. These statements allow you to define how my data is going to look like. That, okay, this is going to have something like this is going to have something like these. These statements are create and all the statements. Okay, these can be create, these can be drop, these can be truncate. I should not truncate. Truncate is not actually a data definition language. Then the second thing can be query. For querying in a database, what are the statements that we had actually used? One most prominent statement that we used for query in a SQL database was select. So that is a SQL statement that is used for selection, for query, right? And the third thing can be manipulation. These manipulations can be insert, update, and all those things, right? Insert this, do this, and all those things. Okay. What is one more important thing? One more important thing is who actually has access. Who actually has access to my table? Because data is very private, so you can't give the access to everyone, right? So you need to have some kind of control of who has access to the data. So in a SQL, the database administrator actually gives you a control that, okay, there is a user this who can actually create who can actually write to this data, or this user cannot write to the data but he can only read. So these control statements can be grant and revoke. So in a SQL, all the statements can actually be segregated into these four things. There can be a definition statement, which can be creating, dropping. This can be querying, which can be like select. This can be manipulation, inserting something or updating something. And these can be controls. These controls are allowed, these control statements are there to, give some read writes or only write writes and all those things to the database management system. Okay, so these are the four things that are there in this. Now let us actually discuss some, some tricky kind of thing. Let us discuss one tricky question that is normally asked in a database interview, and then we will end. The question is that, hey, you have to create a new table with structure, with exact data structure of another table. Okay, suppose there is a table called students, and you don't know that there is a table called students. You don't know this. Okay, so there is a table called students, but you don't know what is inside this table. So there is, suppose, ID, there is name, there is 2-3 more things, but only you know that there is a table called students, and you need to create a table called students copy, which should be having the exact same structure as the students table. Without knowing that what is the structure of students table, how can you do that? So this is actually a very tricky question that is normally that can be asked. So like, how can you do this thing? Anyone has any ideas here? Let us try to see what a select statement was doing. Select statement actually returned me whatever the data was present in my table, right? So if I don't know students table, at least I can run this select query to get the data in that form, right? So I can still get select star from students. Okay, but then what will I do? Now I at least know that what is in the data. What is the structure of students table? But what should I do now? What can I do? I need to store whatever was the structure that came from here into some other table, right? So SQL allows you another keyword, which is into. I say I select star into student copy from. Now where am I selecting from? I'm selecting from students, right? Okay. What will this thing do? What will this statement do? If my statement is only this particular thing, what is it this going to do? Into does nothing but copy everything that was in the first table as it is to the next table. Okay. So for example, if students table had 1A XYZ, 2B ABC, and 3C DEF. Okay. So this statement, this is the students table. This statement will actually just copy everything as it is into the students copy table. Okay, but I don't want the data. I only want this structure. How will I do that? I can say, because I have written a select statement, then I can have a where clause, right? Okay, I will have a where clause, but what to put in the where clause? I need to put something in the where clause such that none of these rows actually get carried forward here. So the statement should be something that is always false, right? So that nothing from here gets carried forward here. So what can that statement be? One very hacky thing is where 3 is equal to 4. This statement can never be false, right? This statement will never be true. This is always false. So select star, when the select star thing gets the table structure, it creates a new table, student copy, because we are putting into here. So it creates a student copy, but because the where clause was never satisfied, we actually never put anything there. Okay, or actually we could have done where 0 or where false. That would have also worked perfectly. Okay, great. Now let us actually discuss some of the aggregate functions of the in SQL that are present in the SQL, because that is something that people tend to miss out, because otherwise you have to see the documentation. Let us quickly discuss that, and then we will be ending the today's session. So let us discuss aggregate functions in SQL. Okay, so let us just list them down, and let us see what those are. The very first function can be average, AVG. So this function takes in a list of values. And returns the numeric mean of them. Okay. One more function that we had actually discussed in the beginning of the lecture, in between the lecture, was a count, right? Count statement returns just the number of rows or the number of records that are satisfying that particular statement. So if I just do select count of star from students, what will this do? I'm saying the count statement just returns the number of records that satisfy my select statement, right? So if I have select and I'm saying select everything from students. So what is the count of everything? This is nothing but number of students. So one hacky way to get the number of records that you have is just select count star of students. That was perfectly fine. Okay, let us discuss other functions. That is min. Min also works upon a type of data. Then there is max. Because there is average, then obviously there also has to be a sum. There is first and last. What are the first and last doing, by the way? I mean, like, people tend to get confused by first and last. What is the, I mean, like, how are they going to be decided? They're going to be decided by the order in which the rows are returned. So the first will return the first element in the order in which select statement would have returned the values. Are null values counted? Yes. I mean, like, if the whole row is null, but it is still present, so yes, that will be counted because that record is still there, unless you have maintained primary key constraint, in which that case it will anyway fail, right? Yeah. So similarly, the last fetches the very last particular record for that particular element. Okay. When we were in the middle of the lecture, what we found about that? What did we observe about these aggregate functions? These aggregate functions allow you to group by. I mean, like, they are used with group by and having, right? So these are the aggregate functions when you aggregate upon something, when you are doing an aggregate. So let us say I am going to take average of all males. Suppose the question that comes to you is that, hey, given a student table where student table is something like ID, name, gender, and score. Okay, you have to return average of males and females respectively. Okay, so the very easy question, very easy version of this is that, hey, I just need to return the average of all the students, in which case you can just do select average of score from students. But now you have to select average of males and female in different groups. How will you do that? In that case, you will have to group those students by their gender, right? You will have to group the students by their gender. So you will still have to select average of score from students. But now all the students are not one group. All the students are not one single group. There are multiple groups. And how are those groups being made? Those groups are being made by their gender. Okay. Select average of score from students, group by gender. Okay. So this is how the group by statement comes into effect. I hope that is clear. Okay. Now let us actually discuss these are the functions that are aggregate functions. These are working upon a set of data. There are also other functions. I mean, like, many people feel that, okay, it's very difficult to, I mean, like, it's normally a better choice to use a programming language along with, I mean, like, SQL. Otherwise, it's difficult to write a lot of things. But actually, SQL has inbuilt scalar functions. So what are those scalar functions? These take in one value and return one value. So basically, like in multiple programming languages, suppose you have a capitalized function, right? Suppose, like, in, let us say, in Python, you have a capitalized function. Actually, let us write those functions in SQL only, so as to not confuse people. So let us, in SQL, there is a function called uCase. If this function is nothing but this takes in a string and returns uppercase version of the string. Similarly, there can be lowercase as well. Okay. Then there are multiple other functions. There are concatenation of different strings. Then there are some mathematical functions which are actually useful. These are rand for random. Then there are round. One of the most important functions that I've actually personally used in my, in real life environment is the timestamp functions. So, like, if you are working with, let us say, data warehousing solutions like Redshift and all those things, timestamp SQL functions are very actually useful. So these can be like to timestamp. Then there can also be now function that returns the current date and time. So one thing, like, most people think that SQL is just about the query language, it's just about querying, but it actually has a very strong set of inbuilt functions that are available directly that you can use and do a lot of tasks that you can actually probably do with only programming. I mean, like, obviously you can't do a lot, many of them, but I mean, like, it's more than what normal people think to be. Okay, one thing actually we missed out in the medium of the lecture was keys, right? We actually missed discussing them in detail. So let's just throw a brief light on them and then we'll be ending it. Let us discuss primary keys and foreign keys and how to create those and foreign keys. Even before we discuss primary keys, let us actually discuss a term called as candidate keys. Candidate keys are a set of column values which can uniquely identify every other value. Select a set of columns, actually, set of columns which can uniquely identify every other value in a record. What do we mean by this? So basically, let us take care of a student's key. Let us take care of a student's table again for the last time. So let us say that student has an ID, he has a name, and let us say he has marks. Okay, and that's it. Or let us say even as a gender. Okay. So let us say the student with ID A has name A, score 20, and gender M. Then ID student 2, he has name B, he has score 30, and gender female, he has student 3, he has name C, 31, and male. Okay. So suppose I just tell you the ID of the student. If I just tell you the ID of the student, you can directly go and say that, okay, the student with that ID had this name, had that score, and that male. Okay. So I mean, like, if you just know the ID, you can know all these three things, right? Let us only consider this table, the current values in this table. Do you think in this current value, name will also be uniquely able to identify all the other attributes? If I tell you that please get me data where name is A, please get me data where name is A, will it be able to uniquely identify all the values? Yes. In the current set, it will be able to, because there is only one person with one name. So A has only one person, B has only one, C has only one. So if I only know name, I can directly get the score, I can directly get the gender, and directly get the ID. Is gender enough? Is gender enough to get the data? No. Gender is not enough to get all the other values of the data set, because there are multiple people who have the gender male but have different name, different ID, and different scores. So the columns, that is for this example, name and ID, that can uniquely identify every other values are candidate keys. So candidate keys can be a single column or a set of columns. What is primary key then? Primary key is the key that the DBMS uses to uniquely identify a record. Okay. It can also be a single column, or it can be group of columns. Okay. So let us see the student and books table that we had actually written above, right? Above we had actually written a student table where what we had was that, hey, which student has rented which books. So there we had a student ID and book ID, right? So if student 1 had taken book 201, he had taken book 202, he had also taken book 203. Then student 2 has taken book 101, he had also taken 202, he had also taken, let us say that there is a student 3 who has taken 203. Suppose these are the students and this is the table. What do you think can be a primary key of this table? Can it be only student ID? Can it be only student ID? No, because there is no, I mean, like, if I just tell you student ID, you can't uniquely identify the value. This student ID is associated with this book ID. I mean, like, there is this thing, this is also associated with this is also associated with this. So basically primary key can be can be the set of columns whose value, if you know, you can uniquely identify a row. You are guaranteed to return a single row. Okay, so for this particular table, the primary key will be student ID, book ID. Both the columns together constitute the primary key. And let us actually discuss how will we create a primary key. I mean, like, in a SQL statement, how will we create a primary key? To create a primary key, you can either do, the very first way in which you can do that is while creating table. So while creating table, you can do create table You tell the name of the table. Let us say that the name of the table is students. You create table students. In this table, we are actually maintaining student ID and book ID. Let us talk about this thing. Let us say here we maintain the ID as this. Okay. So when we create a table, we have to tell what is the name of the column. And then we also have to tell what is the data type of that column. So let us say that ID is an integer. Okay. And I mean, like, let us for now keep it as it is. Then we say that, okay, we are also storing a name. Name is nothing but a string, right? In SQL, a string is a varchar. It's a variable character of how many characters max? Let us say it's 255. So at max, that can be 255 characters. And then here we have, let us say, score, which can also be an integer. And let us say we finally have a grade. I mean, like, let us say we don't have a gender for now. Okay. Then we have to decide the primary key. So we can write primary key, and in the parenthesis, we set what that primary key is. Okay, that is one way. While we create the table, we actually write what is the primary key going to be. But suppose you had actually created the table and you forgot to add the primary key. What will you do? If you forget to do something that you had actually written while creating a data or while defining the data, you can use the alter keyword. Alter keyword is used to alter the initial data definition that you had done. So you can do alter table students where and you first you say that I am now going to alter my table. So that means I'm going to add something to it. What I'm going to do, I'm going to add primary key, and that primary key is going to constitute only ID. That is how I use the alter keyword and get this particular thing done. Okay, so that is about the primary keys. Let us actually briefly discuss, I'm like, before we come to foreign keys, let us actually briefly discuss the constraints. Okay, so I also want that, hey, I tell you that there should not be any student whose name is empty. Okay, I don't want any student whose name should be empty. Okay, that means I want that student's name should definitely be present. So SQL provides us a list of constraints that we can use upon our data definition. Okay, so one of those constraints can be unique. Then the other constraints can be not null. Then there are other constraints like that can check a particular value. That, okay, unique constraint says that value in a column or a group of columns should never be duplicated. Okay, not null says value should never be empty. Then one of the constraints that we have discussed is primary key. That primary key by default says that it should be unique and it should be not null. Okay, then there is also one more constraint that we can say default. So I tell that, hey, if I somehow miss to give the value of a particular column, please set it to this value. Please set it to the default value. Okay. Then one thing can be check. This check statement can actually verify that a value is satisfying a particular condition. For example, I can say that suppose I also had a gender here. So I can say that it's a gender and it's in character. Okay. Then I can maintain a check that, hey, gender should be only M or F. Okay. So this is what this is what we maintain by gender, that, okay, I put a constraint that, okay, there's no predefined constraint. So let me actually create my own constraint that, hey, the value of gender should only be M or F. Okay. And the next, there is also one more constraint, which is the foreign key. And let us discuss this foreign key constraint now. Okay. So what is a foreign key? When we actually were creating the original thing, when we actually created the employee table in above, what we had actually done, we had two tables, right? So the very first table that we had was employee data, in which there was an employee ID, his department, and let us say his title and all those things. Okay. Let us say we had this table. And the second table was, let us say, employee salary. And this had employee ID, and this also had salary. Okay. So if we have these two things, does it make sense? Does it make sense that, hey, there is an employee, but an entry corresponding to him is not present in the employee salary table? Does that make even any sense? No, right? Because if there is an employee here whose department is, let us say, tech, and his title is, let us say, CTO. Then there can be another ID 2 whose department is, let us say, program management, and whose title is, let us say, I'm like, let's say it's a general one, it's program management 1. Then there can be another person 3 who is also a program manager. Let us say his title is PM2 and all those things. And let us say there's 4 who is in tech and he's software engineer 1. Let us say these are the rows that we have. And corresponding to ID 1, I have a salary, let us say 200, 2000, let us say, and I have a salary 2, this is 3000. I have a salary 5, I have 6000, and I have a salary 3 who is, let us say, 4000, and I have a salary 4 who has, let us say, 2000. Does this make any sense? I'm like, there is a salary of an employee, but that employee does not exist. This does not make any sense, right? I mean, like, there should not be. I mean, like, there should not happen that, hey, in employee salary there is an ID. There is an ID, but that ID is not present in employee, right? So we need to ensure that if an employee salary is present here, that employee ID should also be present here as well, right? So we can add a foreign key to the employee salary table, but what should that foreign key reference to? That foreign key should refer to the ID column of the employee table. Okay, so what can it do? It can say, I mean, like, how can we add this? I can say that, hey, when I create the employee salary table, I say create table employee salary. Okay, when I'm creating the table, I need to have an ID. Then I also, this is an integer. Okay, and I also need to have, let us say, the salary, which is also an integer. Okay, now I need to add a foreign key. What is the foreign key upon? Foreign key is upon this ID, right? Foreign key I add upon this ID. But what should this foreign key refer to? What should this foreign key refer to? This foreign key should refer to ID in employee table, right? So I say foreign key ID references, this references employee ID. Okay, so this is how I create a foreign key. If I forget to create foreign key, I can just, I mean, like we add primary key later, we can do alter table foreign key, alter table employee salary, alter table employee salary. And then what I do, I have to now add a foreign key, right? So I add a foreign key. I add a foreign key upon which column? I add a foreign key upon the ID column, and this references employee ID. Okay. So this is how I can add a foreign key later as well. Okay. By the way, I mean, like, anytime when we have to do a modification to the data, whenever we have to do any modification to the data, we actually have to use this alter command. This alter, as we know, is a data definition thing, and this can actually, I mean, like, alter the table, alter the definition of the data. This allows you to do that. Okay. Okay. Finally, I think there is one more confusing thing that I actually saw someone in the comments. What is the difference between drop, delete, and truncate? What is the difference between these three things? I mean, like, these three things in English wise mean the same thing, right? These three things mean the same, that, okay, you are deleting something probably. Okay, but is there any difference between these things? Why does SQL has these three things? I mean, like, why? Okay, so the difference between these three things is that, hey, delete is used to delete a row from a table. Delete is just opposite of select. Okay, in select statement, you select some set of tables to view, but in delete command, you select a particular set of records to remove them from your SQL table. Okay, so I mean, like, what you can do is, suppose you have to delete all those students. I mean, I suppose your university decides to remove all the students who had less than 40 marks. So what less than 40 scores. So your university can do delete from students. Okay, then you can use everything here where what you use in select statement. So you can use everything here. So you can select where, let us say, score is less than equal to 40. This will do what? This will just remove every, I mean, like, every data from the student table, from the students table that had a score in which a student existed who had a score less than equal to 40. That is a delete command. Then there is also a truncate command. What this truncate command is used to do, this deletes all the rows. This deletes all the rows. But table is still there. But table and its definition, constraints, everything is there. Definitions, constraints are still there. And then the final thing is drop. Remove every existence of the table. Okay, remove complete existence of the table. So let us actually give you an intuition of this with a diagram. Okay, suppose we had a table like this, in which we have an ID, in which we have a score. Okay, let us say we have a ID 1 whose score is 50, ID 2 whose score is 60, ID 3 whose score is 20, ID 4 whose score is 10, ID 5 whose score is 70. Okay, let us run 3 commands here. Let us run, and this is ID and this is size. Okay, this is suppose the table, and let us say the first command that we run is the delete from students where score is less than equal to 40. What will this return to? This will change it to ID and score, and this has 150 because this is there, 260 and 570. Okay, other things will get deleted. You do truncate. If you do truncate, you are only remaining with ID, score. No data is remaining. Okay, nothing else is remaining. And if you do drop, nothing is remaining. I mean, like, there is complete empty thing. Nothing is repeating. Yes, Rahul, where clause can be applied in delete. That is what we have written here, right? Yeah. So let me actually give an example of how to write the truncate command. To completely remove the students table, you can do truncate table. I mean, like, to truncate all the data that is there in this. So you can do truncate table students, and to remove the students, I mean, like, to go into this thing that there is no existence of students table at all, you can do drop table students. Okay, so they completely remove the data, or the second thing, the drop table actually completely removes the whole existence that is there of that data. Okay, yeah, so that's all that I had from my side today. I hope you liked the session. It went for around 2.5 hours. So yeah, thank you for being a very patient listener. And okay, and by the way, guys, I mean, like, we have actually a very I mean, like, all these things we have actually written into a well-defined article as well on the InterviewBit platform. So that is present on this particular link that I just pasted on the chat. So please, I mean, like, if you want to practice all these SQL statements, you can actually write those SQL statements there and see if the SQL code that you wrote was also good. Okay. Yeah, awesome. Have a good night. Please stay safe and stay healthy.